Hola, hola, hola. ¿Me escuchan bien?
Sí, ahí está ya.
Sí,
Ahí
ya
suena bien.
entró. Hola, hola, hola. 1, 2, 3. Probando. 1, 2, 3, 4, 5, 6, 7, 8, 9. Continuamos en el segundo día de COLOMBIAMAR 2021 y séptimo Congreso Internacional de Diseño e Ingeniería Naval, los cuales, dadas las restricciones por la pandemia, hemos decidido realizar de manera digital.
We've decided to do this online. At this point, we send a greeting to all of those connected through the COLOMBIAMAR website, and we invite you to share your participation in this conference through your social media by using the hashtag COLOMBIAMAR 2021 and mentioning at COLOMBIAMARCOL and at COTECMAR. We particularly appreciate the support of our sponsors and for being part of this issue of COLOMBIAMAR 2021. Okay, now we give the floor to the Vice President and Foreign Relations Officer of our nation, Dr. Marta Lucia Ramirez. Good morning. I'd like to send a greeting to Admiral Luis Fernando Marquez, the new president of COTECMAR. Also, I send a warm hug to Admiral Oscar Bascon. He's always been in our prayers, and we've been begging to God for his recovery and our support to his wife. COLOMBIAMAR is bi-yearly event devoted to the development of the naval, maritime, and river industries by COTECMAR, as well as the CIDIN conference. I feel very proud because when I was defense minister back in 2002, along with Admiral Mauricio Soto, the push that COTECMAR needed to try and prevail. And now we have this company that all of us Colombians are proud of. This year, unfortunately, because of the COVID-19 pandemic, the business showcase has been postponed for 2023, but we will develop the Naval and Maritime Engineering Conference online, which is a scientific and academic space for technological transfer with the participation of different stakeholders, the productive, scientific, financial sectors, aiming at developing the shipyard industry from the Vice Presidency of the nation and from the Colombian Ocean Commission. We've structured 11 strategic cornerstones for the development of this huge potential that we have, as we are one of the 23 countries in the world with coasts on both oceans, and that strategy is basically that of the shipyard industry, which actually feeds into other sectors such as the development of seafarers. It is a link that gets assistance from others, but which gives back a lot of support to the sectors related to the development of the oceans and the ocean industry, trying to generate jobs and welfare for all Colombians. And that allows for many more Colombians to be part of ship crews, but they can also become engineers, technicians, welders. There are so many specialties within the shipyard industry. Also, another strategic base that also favors the development of the shipyard industry is ship flagging. And as you know, we have just passed law 2173 of 2021, which provides for that regime for ships and naval devices in our country. This was a strife of many years leading up to this law. And in this manner, we can appeal to shipping companies and shipbuilding yards so that they will flag their ships under the Colombian flag, which many of such vessels will receive specialized services by way of repair and maintenance on Colombian coasts. In different places of the nation, both on the Pacific and Atlantic coast, thus generating not only the growth of the shipyard industry, but also job opportunities for the inhabitants of the 47 municipalities settled on the two coasts of the country that will provide for maintenance, servicing, provision. We will also develop naval repair workshops, many shipyards such as COTECMAR. We will, of course, prioritize COTECMAR as a company, but we also want for other shipyards to step in now that Colombia just welcomes Singapore to the Pacific Alliance. We know that there is huge potential looking at what the ocean, what the sea actually offers. Korea is a country with an impressive naval development. We hope we can also bring over Korean investment into Colombian shipyards. And this is a conference that helps the accomplishment of these objectives. It raises awareness about the potential of our oceans and positions Colombia as a two-ocean country. And it develops those 11 strategies summoning the private sector. And at this forum, we have an opportunity to promote the growth of the naval, maritime, and river industries from academia, from a scientific and technological perspective, and the huge technological developments, but of course, also the business perspective, so that the industry and its companies can share experiences and knowledge around innovation with breakthroughs and technological progress within the sector, and all the while generate commercial ties with an international projection. Who would have imagined uh, only 15 years ago that Colombia would be exporting naval products, and we will continue to ramp up the various specialties in production and also diversifying all of these export markets. This is a great challenge. The attention to our rivers, speedboat units, everything we require to do monitoring, patrolling, control, so that we can also achieve tourist development around our rivers, sailboats, so many good things, and we will increasingly see the national participation. Over these 2 days of knowledge exchange, there are going to be a couple of forums looking at the different proposals from the shipyard and maritime industry, trying to propel the competitiveness of our country. In the first forum, named challenges of new technologies applied to the digital transformation and the naval industry 4.0, all of those challenges will be posited, and what the new technologies bring about, and of course, build a proposal in terms of the roadmap that we have to follow to be able to implement in the various shipyards and naval stakeholders. In the second forum, entitled The Shipyard Sector as a Competitive Proposal for Opportunities Issues, we will analyze the historic evolution of this sector from the economic, social, and technological perspectives. And there is going to be a discussion around the issues, the bottlenecks, as well as the opportunities that will allow for the construction of proposals to the consolidation of the sector and to a higher international competitiveness. That's why I insist on the fact that we have to think big. We have to do benchmarking. We gotta understand that we're still small in terms of naval development, but for instance, Korea accomplished a level of growth, and today it's coming out on top in this naval industry. From the national vice presidency, we have worked to turn Colombia into an ocean power, and this is one of the objectives we set out to accomplish with President Duque when we started this administration, and that's why I'm happy to say that Colombia already has a roadmap. We need to capitalize on the ocean potential of the nation. That's why we issued the plan for Colombia to become a sustainable ocean power. Within the next 2 decades, Colombia has got to generate jobs and development and spearhead this process through the 11 strategies and capitalize on the fact that we have coasts and two oceans, and we have over 14,000 kilometers of waterways where only 5,500 are to this day navigable. That's why we Colombians have to push this objective forward so that more people can become trained in these professions that imply the maritime, naval, and river growth and the sustainable use of our coastlines, the awareness of maritime spaces, and how using that should go hand in hand with due care. This is a concept that is totally integrated to the use and sustainability components because it is high time for Colombia to stop turning its back to the ocean. And the shipyard industry plays a key role, which will continue to support from the Colombian Ocean Commission so that our country can become a regional hub of naval growth. Those capacities can be disseminated through the international community by means of such important conferences as CIDIN. The academic commission that worked with us back in 2019 and who delivered their report a year after also prioritized the ocean component. That's why the Colombian government's development plan is the first one with a chapter devoted to the ocean. That's why this CITIN conference and business fairs such as COLOMBIAMAR become ever more relevant as part of our national objectives. This is what we're working at in order to make the work activities more dynamic, all of which are so important for the national economic activation, our industrial growth, and manage for Colombia to gain a leading role in the international market. Thank you so much and congratulations on this fabulous event today. Okay, dear Vice Minister, thank you so much. And now we will hear some welcoming words from the Commander, Admiral Javier Pérez Garcés.
En el marco de los eventos convocados
Within the framework of the events organized by the Science and Technology Corporation for the development of the naval, maritime, and river industries, COTECMAR, it is particularly important for the academia, enterprise, and government relationship towards the maritime growth of the nation, which is essential as part of our Navy's strategy. The COLOMBIAMAR Digital 2021 is the 7th conference of naval design and engineering carried out from the 1st to the 3rd of September with high-level presentations around 13 topics: design and production of ships, shipyard 4.0, and competitiveness of the shipyard industry. On the one hand, COLOMBIAMAR as a space created for promoting the growth of the naval, maritime, and river industries from academia, from science, technology, and business, so that the industry and all of its enterprises can share experiences, knowledge, and innovation with a technological scope typical of the sector and also strengthen business ties with the international community. Also, the Design and Naval Engineering Conference as an academic venue for technological transfer through the participation of different stakeholders within the scientific, productive, technological, and financial sectors actually integrate the shipyard innovation sector. This is a huge opportunity to move the industry forward in attracting a lot of business, with all of which has become the backbone of the sector in the region, bringing together the most important representatives of the naval, maritime, and river sector, both of the nation and the continent. Thank you so much, Commander. And now, again, we greet Miguel Andrés Garnica, Ship Captain within the 7th Ship Design and Naval Engineering Conference for some opening words.
Buenos días para todos. Bienvenidos a esta segunda.
Good morning, everyone, and welcome to this second day of the International Ship Design Enabled Engineering Congress CIDIN 2021. To begin with today's program, I would like to invite Dr. Reinhard Schultz as our keynote speaker, an associate professor of propellers and cavitation from the Technical University of Berlin, who will talk about the optimal design of low noise propulsion systems for Navy and research vessels. Dr. Schultz, who was born in 1947 in Germany, has undergone studies in electricity and has a PhD in mathematics from Humboldt University of Berlin. The main topics of research interest are related to the global optimization of propellers, optimization for low noise propellers and redundant propulsion for vessels. In 1993, he was a senior project manager for the design of propellers at the shipbuilding center in Potsdam, Germany. From 2007, he has been working for SVA Tech, and from 2016, he's performed as an associate professor of propulsion and cavitation at the Technical University of Berlin. I now give you Dr. Reinhard Schultz.
Good morning. Thank you for the invitation. Good morning, ladies and gentlemen. My name is Reinhard Schulze. My most time I spent, working time spent the SVA in Potsdam. I work on this a long time, and besides the rest of the time I spent the Technical University of Berlin. Please let me introduce at first a little bit the company in Potsdam, and after this, I will speak about a description of the propellers in the sense of geometric description and numeric. Then what propulsion systems we consider and what we do with the design of low noise propellers. We use the so-called inverse methods. I give some examples here. We speak about propeller as a noise source of different sources, cavitation, hydrodynamic effects, and mechanical effects. Let us speak a little bit concerning the flight structure interaction, especially in context with different materials or propeller materials. We speak a little bit concerning the recalculation of results of model tests in the sense of hydrodynamic properties, and at the end we speak the problems of sound and water in correspondence to the measurements in cavitation tunnel and model basin. Our company was founded in 1953 after the Second World War in the formerly East Germany, and was formerly a part of an engine manufacturer in Rostock. After the unification of Germany, our company is a company with limited liability, and we have some qualification for quality requirements. And 2004, we founded a subsidiary, a daughter, so-called SVA Potsdam, SVA Tech. I am part of the SVA Tech, and our company has about 50 employees. We have the following test facilities. We use 3 model basins. In-house, we have a model basin of 280 meter length and width of 9 meter and depth of 4.5 meter, with a maximum carriage speed of 8 meter per second. We use at the Technical University another high speed carriage in a model basin up to 12 meters per second, and in the Technical University also a shallow water basin with a maximum speed of 4 meters. In-house, we have a cavitation tunnel with 2 test sections. One test section has a square of 600 times 600 millimeter with a maximal speed of 12 meters per second, and the big test section has 1850 times 1850 millimeter with a maximum speed of 7 meters per second. We have a lot of technical devices, a lot of computer technique to carry out good CFD calculations. Here's an example for theoretical submarine. And our main focus, or one of our main focus, is a propeller design with we use a special optimization techniques, and in the center of interest is here the usage of lifting surface methods, coupling with ANSYS with the FEM finite element method tool, and coupled with some CFD tools. We have specialized for the propeller design for Navy and research vessel as propellers with high performance, propellers with a very wide cavitation bucket. We use a special optimization technique. We use profiles with special variable camber distributions, and we use in general for low noise application propellers with finite chord lengths at the tips, like here on this ship. We have in our company developed special devices to reduce noise from cavitation, especially near the hub. Here's a so-called hub vortex vane for reduction of the hub vortex cavitation. On the left is such a hub applied on a submarine propeller, and we have developed special devices for the reduction of cavitation on the radar. As you see here on the right, a conventional radar with area of cavitation at the radar, and with this special design twisted radar without cavitation. Also, we make measurements at full scale. We measure the power consumption at the shaft. We carry out hydroacoustic measurements on vibration above the propeller. We have a small test rig here on the right. This is a test rig for measuring the friction on flat plates. You see here in the middle a coated flat plate with a special silicone-based coating to reduce the fouling of the propeller, and maybe also for increasing the propeller efficiency. The propeller here described as some examples. Here's a research vessel, so-called Planet. Here left, on the left side is a fishery research vessel Soleil, built from the Phasma yard. On the right is a propeller of the Soleil, and on the upper right is a propeller, picture of the propeller of the Planet. The propeller can describe in 2D, can be described as 3D representation. For our main focus goes to the description of the propeller geometry by a matrix of real numbers. This matrix results from a discretization of the functions along the radius for the pitch, camber, skew, and rake, and so on. Here's an example. The hydrodynamic properties is usually described by the profile characteristic of cuts through the blade by cylinders. And the complete hydrodynamic characteristic will be described by real numbers as a function of the advance coefficient, so that we can calculate or that we can measure the thrust coefficient, torque coefficients, and in the center of the system also the open water efficiency, or in addition here also the pump efficiency of the propeller. That can be represented graphically as the open water characteristic, independence of the advance coefficients, or more detailed for all situation of the propeller behind the ship, for forward moving, for backing, for crash back and crash ahead by so-called 4-quadrant measurements or the 4-quadrant description. This is here represented. All these possibilities of inflow to the blade is here on the left side down represented, and here is a complete 4-quadrant measurement. Usual for the normal sailing, we use the open water characteristic in the from the first quadrant in the range of 0 to 30 degrees, and the other is for the off-design situations for backing, crash back, crash ahead, and so on. We have in the past in the SVA developed, or we were part of a development of different propulsion systems. We have a strong cooperation with Shuttle in the development of the twin propeller. We have carried out designs for counter-rotating propellers, ducted propellers, CPP propellers, and well-known fixed-pitch propeller, of course. Also, we consider in general not only single-screw ships. We have developed and experiments and tests carried out for triple-screw ships. This is not only in the model basin, also in the cavitation tunnel. This requires a special technique in our for our test facilities. Here's an example of a low noise ship. It's the submarine 212. This submarine has a surface of 20,000 square meters. This surface generates resistance, and in comparison to this area, to this wetted surface, the propeller has an area of less than 10 square meters, and all losses from the hull must be compensated by the propeller in a much smaller area. This ratio is here roughly more than 200. That means the focus for the noise generation goes to the propeller. One of the main, also matching engines and so on, but it's not our interest, in front of our interest. The design of low noise propellers is in general a multi-staged process. I have here pointed out these stages. In general, we start with a preliminary design. Then we carry out the design in general as a multi-target optimization on the basis of a potential flow codes. And then we calculate the hydrodynamic characteristics, the acoustic characteristic. We use different tools for the cavitation forecast, for the calculation of pressure fluctuations. We use the CFD calculations, and then we carry out in general model tests for cavitation for the global quantities like thrust and torque, pressure fluctuation, acoustic measurements. And after the results in model scale, we need the correction of all measurements in full scale. This is not so easy. The preliminary design, we use in general polynomial coefficients based on the Wageninger propeller series. The actual design process, we use potential flow code, the self-made vortex. And from Poland, we use from CTO the program Anchor 99. The advantage of Anchor 99 is a calculation of pressure fluctuations, but the accuracy is not so high. And after this, we make a verification of all calculated hydrodynamic properties based on the potential flow results. We apply then for each of these methods, the polynomial coefficients, the potential flow codes, maybe also the CFD tools, the so-called inverse methods to optimize the propeller. On the basis of Wageninger polynomials leads this to a program here denoted by DNO CTRL. That means we can optimize the diameter and revolutions numbers independence of the requirements for the ship. And then we start with a potential flow code. And this optimization tool is named by VTX opt. What is the sense of inverse methods? At first, we define an evaluation criterion, a function, f defined over a matrix of real numbers. I have introduced these metrics. Included in this matrix is in all geometric characteristic of the propeller. That means pitch distribution, camber distribution, and so on. And for fixed advanced coefficients, we look for the best efficiency, for the lowest cavitation number, and have to introduce wanted KT or KQ value. And the evaluation criterion is constructed such as this function is minimal, has a minimum value, if these boundary conditions are fulfilled. And then we use a normal mathematical optimization tool to minimize this function. That means the minimum value is then the wanted optimum geometry of the propeller. For the mathematical, we use for the mathematical optimization algorithms, so-called Newton-like tools like Davidon-Fletcher-Powell algorithm, and this tool needs smoothness of the function g, what is not so easy to prove this characteristic, and is not so smooth this function, then we use a so-called direct search algorithm from Jablonski. Both algorithms are realized in this optimization tool. The optimization of the propeller geometry uses a multi-point optimization. That means we need a boundary condition for the power or the thrust, and we have to consider not only the here the KT value in 1 point for one advanced coefficients to make the efficiency maximal and the cavitation number minimal. We use in addition additional conditions for other advanced coefficients left from this and right from this design point to make the cavitation number minimal. This is also possible for Q value. That means we have to consider 1, 2, 3, 4, 5 conditions to have an optimum propeller. To have a good criterion for G, a good minimum criterion is not so easy to define, but this is possible. In general, we need some iteration steps then. Here at first, this is the optimization. The second is the calculation of properties. The calculation of pressure pulses. We need an additional program, in general Anchor 99. We need a finite element method for calculation of natural frequency of the blades. We need this for stress calculation in the wake field. And we use in general the commercial program ANSYS. Then we carry out open water test. We make a Reynolds number correction for the hydrodynamic characteristic. We carry out cavitation test. We make acoustic test and calculate it all in full scale. This is in general 1 or 2 or 3 times is a loop for 1 or 2 or 3 times. For the planet propeller, we use 2 iteration steps. For the fishery research vessel, we have needed only 1 iteration step and has a good result. Here is the result of the propeller of the fishery research vessel as a result of this optimization. And I hope that we can hear this correctly and you can hear. Oops. This was noise at the shaft of the original propeller. Here is the device on the shaft to record the accelerations on the shaft. And here we have the noise of the new propeller. Can you hear this? Can you give me an answer? No comment.
I can hear it.
This is again the propeller and the behind view and the characteristics, the measurements of the acoustic properties of this propeller measured the test range for acoustic ship measurements in Germany. That means the propeller has fulfilled the IGES recommendations for fishery research vessels. The origin for the noise of propellers has different parts. One part of noise is in general, or one strong part is the cavitation property of the noise. And hence we think about the acoustic properties of cavitation. We start with a single bubble characteristic. We measure the characteristic of generated bubbles, and we speak about acoustic direct measurements in model scale. The theoretical background for the single bubble cavitation is a so-called Rayleigh-Plessing equation. This is an ordinary differential equation of second order. but this equation has singularities. It's not so easy to integrate this differential equation. And the simplified Rayleigh-Place equation is a so-called linear equation. And this linear equation describes the oscillation of a single bubble without implosion. Here you see the results of numeric calculation of the numeric integration of the Rayleigh-Place Gleichung for different pressure gradients, for different order pressure frequencies. And we have analyzed acoustical single bubble noise. This is a noise of a single bubble in a 100 cycles per second pressure field. And if we have 100 bubbles, such bubbles, which a statistical distributed position, then you hear this noise. Oops. This test rig is at the University of Bochum and will be used to test materials for erosive influence of erosive cavitation to material probes. You have here sonotrode. This excited by 20 kilocycles per second. Below this is a probe, and we have in this area of the probe acoustic sensor mounted and have measured these acoustic signals. The exciting frequency is 20 kilohertz. This is a small line. And following the linear equation, then we can see here a maximum for a mean bubble diameter of mean bubble radius of 1 millimeter and a second maximum for 0.1 millimeter. This is the answer of bubbles generated by ultrasonic excitation. The stroke of the piezo actuator was 20 micron, and the distance between the exciter and the probe was 3 millimeter. And we can measure in this device the erosion effect to materials. We see here two probes, and one can the weight of erosion effect can be measured, and we see here the loss of material in the dependence on site for two different probes. The blue one is for normal copper-based propeller bronze, on the other was another different material for submarine propellers. Acoustic measurements in model scale can be carried out by different methods. We have introduced here a new device, directly mounted recorder on the propeller hub. Inside this blue box is a recorder for signals up to 400 kilocycles per second. We want to detect here in this area of high frequencies the erosional effect of cavitation at the propeller blade. The hydrodynamic effects on the propellers, which generates noise, we divide in two parts. The one is the autonomous part. That is the case if the propeller acts, it's a wake field behind the ship. And the other part is so-called autonomous excitation of the propeller by fluid structure interaction. In this case, we speak about singing effect, droning, fluttering, propellers independence of the frequency range. The hydrodynamic effects of main interest is the so-called Strual effect. In general, can at the trailing edge of the propeller blade, this generates noise. And if we have an interaction with the eigenfrequencies of the blade, we come to the singing propeller. Also, we can have vibrations along the surface of the blade. We speak then from Tolming-Schlichting waves, and these waves can also give an interaction between the blade eigenfrequencies and produce noise of the propeller. We have another effect. We have here carried out calculations of the interaction of the propeller with the shaft for no. That means the shaft and the propeller constitute acoustic unit. That means acoustic effects on the shaft can also give noise at the propeller and vice versa. We have here a so-called Campbell plot. On the left side, the stick slip effect on a shaft in a bearing gives us a noise at the propeller. And contrarily to this, on the right, we have a singing propeller here. And the singing effect of propeller is here represented for different revolutions, for different speeds, in a range of very low frequencies, for a middle number of revolutions, and for the highest number of revolutions. In all cases, this propeller produces noise based on a singing effect of the blade. What we can do, we can look for another materials to avoid these effects of light structure interaction. Maybe we can use plastic materials. We can use carbon fiber reinforced materials, glass fiber reinforced materials. And we have also considered propellers made from homogeneous materials, like this application with polyamide. I think Mr. David Fuentes will give us a deeper insight to these effects in his last lecture in some minutes, some hours. If you have measured in model scales the hydrodynamic characteristic we use in general, or we must apply in general, the Reynolds number correction, the ITTC correction method is here represented. In the focus steht a correction based on the drag correction of the drag coefficient. The drag coefficient on the drag coefficient has an influence, the so-called form factor of the profile shape, the friction in model scale at the flat plate, the friction of the flat plate in full scale. This is here represented again for the drag coefficients. We have a form factor. The friction coefficient is generally represented only for one side. Hence, we have here factor 2 and the form factor for profile shapes. In model scale and full scale will be used different formulas. This is ITTC recommendation. And we have changed this form factor for our applications with another formula originated from Thorenbeck. And we use in model and full scale different friction lines. The friction line for model scale from the ITTC, this is a brown curve here, is not applicable for Reynolds number lower than 5.5 because the curve is going down here. And we use another transition characteristic here marked by the pink colored line. In full scale, the Reynolds number has no influence to the ITTC formula. And we use another formula based on Schlichting-Gersten with the influence of Reynolds number and also with the influence of the roughness of the skin. This formula is an implicit representation for the friction. We have on both sides of the equation the friction coefficient, but it's possible by modern computer technique to solve this equation very quickly. Here's a difference of both lines. And here on the top is a comparison of the measurement in model scale for 8 revolutions per second. And this is a full scale prognosis of the efficiency and the KT and KQ value. And the result is to have a set of formulas such that for all measurements with all revolutions numbers, we have the same forecast. And this is nearly fulfilled by using this new formula. For the noise calculation, we need some information for the noise in water. We have different types of spreading. We have so-called spherical spreading, cylindrical spreading, independence of the environment of the ship, of the propeller. And we have losses generated by the water itself. These losses, so-called absorption transmission losses, are strongly dependent of the frequency. In the low frequency range, lower than 100 cycles per second, we have a very low loss, and this increase to higher frequencies. The mathematical background for the analysis is the Fourier analysis and the transformation from the time region in the frequency region. And this will simplify it, not for each frequency. This will simplify it for regions, so-called in general third octave regions. This here described more precisely in this table. Here's an example of task. We have to analyze the influence of propeller. The propeller has a special type of cavitation, and the echo sounder works at a high frequency range, roughly 430 kilocycles per second. And we have here the noise, see here the noise of the propeller, and here the dots of the echo sounder. That means we need information over a very wide range of frequencies. We use in the model busing a hydrophone array with 16 hydrophones. In the cavitation tunnel, we have pressure picks at the ship model, hydrophones in the coupled water boxes in the water camber, hydrophones directly in the flow, mounted, flush-mounted hydrophone at the wall, at the windows. And we use in general, in addition, acceleration sensors at the window and at the ship model. Here is a dismounted hydrophone array. Here is a window of our cavitation tunnel, flush-mounted hydrophones, a camber for a hydrophone, and here is a device for recording the structure bore noise at the propeller, and here are acceleration sensors at the window. In the model basin, we put this hydrophone array, and the effect of the hydrophone is a possibly beamforming of the signals of 16 hydrophone. Here is an example for the frequency of 2 kilocycles per second. That means we can see more precise the propeller at the ship with a 16 hydrophone array. So let us speak a little bit for the correction methods for the hydroacoustic measurements. We divide, or one comment, in the cavitation tunnel and the model basin, we have a lot of influences of noise. We have the carriage in the model basin. We have the gear at the cavitation tunnel. We had at the cavitation tunnel a pump, and so on. And it is not so easy to detect the propeller noise in the complete measured noise. And following this, we divide the disturbations in 2 parts, in the so-called incoherent part and the coherent part. That means the correlation between both signals is correlation coefficient is not 0. At first, if we have information for the coherent disturbances, maybe we have an information based on the acceleration sensors, then we can divide the measured signal in the signal of the propeller is factor times correlated signal and the signal of which is incorrelated to the propeller noise. And if we have this, we use this formula, we have a solution that we can represent the propeller noise as a difference of the correlation coefficient and the correlated noise and minus the incoherent noise. And so the method is described as follows. At first, we measure the background noise here in the cavitation tunnel and use an additional acceleration sensor. Then we determine the incoherent part of noise. This is a measured background noise and the measured coherent noise part. Then we calculate the third octave levels of this signal. Then we measure the same with the propeller, not here without the propeller, only with a dummy hub. Here we measure this noise with the propeller, with the rotating propeller, make the same calculation, comes to the third octave levels, and then we apply the normal IDTC procedure to correct the measured noise levels. Here's an example. Here we have noise measurement frequency and level. We have a lot of disturbances, and we have applied the correction method based off the coherent part. And in the result, these disturbances we cannot see. We see only this is a pressure pulse measurement for the first harmonic. And we can do in the model basin measurements with a hydrophone array. We have a free running model. Here is a Soleil model, and we have measured and represented the noise measurements by a Campbell diagram. That means here is a time in the X direction, the frequency in the Y direction, and the color is a level. For the application of twin on triple skew ships, we divide this ship in two parts, for the triple skew in the middle part and the side part, and measures it alone in the cavitation tunnel, because our cavitation tunnel is too small to put the full ship in this cavitation tunnel, and we can make a combination of all measurements to an overall signal. The full-scale prognosis need distance normalization. I have introduced this with the comments to the spherical and cylindrical spreading. And the IDT gives hints for the recalculation from the measured model level to the full-scale level with unknown exponents here, x, y, z, with some hints to the definition of this. We use this special correction, special recalculation for full scale. That means x is 1, y is 2, and z is 1. And in addition, the IPDC recommended frequency transformation from model scale to full scale, like the ratio of the revolutions numbers. This is maybe true for in the range of low frequencies up to fifth harmonic of the blade frequency, but in high frequency region, I don't know is this correct or not. That means before we use normal correction of the third octave levels, we make a difference from the measured signal with a current component. We can this use also for pressure fluctuation, not only for noise measurements. The pressure fluctuation is a noise in near field. The far field, we speak in general from water noise. For this is an advantage to have an additional sensor, which then this sensor must give us hints for the coherent part of noise, and we can calculate the noise of a multi-skew ship by partition of the ship in more parts and analyze each part alone. Here's an example of full-scale measurements. We carry out this as for our clients also. Here we have applied a hydrophone, set of hydrophone here, only two. In general, we use 3 hydrophones to reduce the influence of light mirror effect. That means the sound reflection at this surface and bottom of the test area. And we have here measured for a CPP application on a ship, the constant speed mode and the combinator mode for the same speed of the ship. That means it's a big advantage to sail with a CPP propeller in the combinator mode and not strongly in the constant speed mode. Thank you for your attention. Thank you very much. And I give back.
Estimado Dr. Reinhard Schulzen.
Okay, dear Dr. Reinhard Schulz, thank you so much for this fabulous conference and your contribution to the state of the art. We have a lot of comments on our social media. I would like to transfer the interest that your talk has generated, that your talk has aroused around the mathematical models, such complex and sophisticated mathematical models employed in the application of high-level research with regards to the design and optimization of propulsion systems and propellers. Very clearly, you allow us to see the edge and the limits of the state of the art at this particular point, and it encourages us to continue researching on these highly important topics for the naval industry, not only in our country, but also worldwide. I would like to transfer some of the queries, some of the questions from researchers who've been texting us through the chat. To begin with, researchers are wondering if there is some kind of a memorandum of understanding from within the circle where you work with other entities, with other institutions committed to this type of research and related, for instance, and very specifically, to propellers for autonomous vessels.
Dr. Reinhard.
Dr. Reinhard, I am going to repeat the question. Can you hear us? Dr. Schulz, can you hear us? There is an interest in getting to know agreements for the exchange of experience between researchers related to propulsion systems or propellers for autonomous vessels, autonomous ships.
Do you know of any? Do you know of any? ¿Conoce usted alguno?
Dr. Schulz, can you hear us? Hello, Dr. Schulz. Can you hear the audio? Can you hear us at all?
La pregunta es si él conoce de algún acuerdo.
Yeah, I think this is possible. that we can change the results, or some results, not all, because we have a lot of orders for clients, but we have 50% of our work is a research part, and this is open. Is this a correct answer?
Así es, doctor Reinhard Schulzen.
That's right, Dr. Reinhard Schulz. We are filled with satisfaction to know that this kind of research is open and available, so that researchers from Colombia can achieve this level of knowledge and expertise someday in terms of the design of low noise propellers. Okay, we have several comments that I would like to transfer to you, and one of them comes precisely from one of the officers of science and technology at COTECMAR. Corvette Captain David Fuentes tells us that this is a clear example of the union between theory and practice within a very significant field in shipbuilding.
Asimismo,
also, we're told from the Naval School for Cadets that this invites us to think about the need of a channel of experience, hydrodynamic experience in the Caribbean region.
Para poder acceder
in order to access this type of experiments practically in real time and be able to generate collaboration with your university. There is another question, Dr. Reinhardt, that I would like to transfer to you, which is about the trajectory and the application of these methods in different shipyards in Germany.
I have introduced these methods at the last conferences in Germany, and our calculation, our correction methods, we will apply for the clients and publish it. These methods. I can send you these papers if you want.
Perfecto, Dr. Reinhardt, muchísimas gracias.
Perfect, Dr. Reinhardt, thank you so much. For us, it will be an absolute pleasure to read a paper of such a high level. And if you allow me, I would like to draw some conclusions from your magnificent talk and recognize the academic trajectory by the hand of the German industry, and you've clearly allowed to see that in your description of the beginning of the company back in the 50s, 1953. We're talking about decades of production reflected by high industrial standards, supported by research, very high research. Okay, for us, no doubt, this is a moment of great learning, because the design of low noise propellers, the study of cavitation, the integration of different materials open up doors so that we can access more and better designs. Mathematical models arouse a great deal of interest, and this is one of the aspects that we would like to address in future opportunities for academic exchange. To wrap up, Dr. Schulz, I would like to ask one last question of you related to propellers with the capacity to absorb shock, referring to inland waterway vessels, river vessels, that in some manner may actually recover part of their form or their shape. I don't know if the proper term would be resilient propellers. This is a concern that we have addressed in different scenarios at different universities, and it totally draws our attention because of how difficult inland navigation is in Colombia because of all of the suspended solids that notoriously affect the propulsion system and the steering system of vessels. Today, President, what can we find in terms of these kinds of vessels with the capacity to absorb these shocks and recover their shape or part of their shape as such, if at all possible?
I think for inland waterway ships, the best possibility is to reduce the noise by better cavitation properties and new materials. This is the answer.
Perfecto, doctor Reinhardt.
Okay, perfect, Dr. Reinhardt. We would like to send special thanks by the president of COLOMBIAMAR and all of the task team. You've provided us with a lot of valuable lessons, and we hope we can count on your participation in future. Greetings from Colombia, and thanks a million.
Greetings from Berlin, and thank you very much again. Hey, David. Please, thank you for you. Thank you for the invitation and the organization. Hope that we can see you again. Shocks. Special pumps is wet water. They have tested different materials, carbon fiber reinforced material, and glass fiber and rubber milk. And our milk is at the highest resistance against against contact with send. And this material can also weld it. Yes. And what you can get. Yeah.
Agradecemos a nuestro chairman y a nuestro invitado, Dr. Schulz. Continuamos con la agenda programada.
So we continue with our scheduled agenda, and we continue with the shipbuilding forum as a competitive bet, opportunities, problems, and proposals. And next, I would like to invite the panel members, Dr. Daniel Toro, Vice Dean, Academic Vice Dean of Universidad Tecnológica de Bolívar. Dr. Toro is an economist from Universidad Tecnológica de Colombia, Magister in Economy from Universidad de Los Andes, and Doctor in Economics from Universidad Estatal de Washington. As a Fulbright Scholar, he has experience as a researcher in the Observatory of the Colombian Caribbean, in the Center of Economic Studies and institutions such as the Los Andes Universidad, the Inter-American Development Bank, and the Agriculture Department of the United States of America. He is an expert in public transportation, education as a social phenomenon, industrial, organizational, and applied macroeconomics. He is currently Academic Vice Dean of Universidad Tecnológica de Bolívar. Next, we have the frigate Captain Vladimir Ibarra. He is a manager of Astinave of Ecuador and representative of a team. Captain Vladimir Ibarra is an electronic naval engineer specialized in electronic defense systems with a master's degree in management and new technologies management. For over 9 years, he was project manager in Astinave with experience in the strategic leadership of portfolio programs and projects for naval defense, security, and the commercial maritime sector. He has worked as head of projects of investigation, research, and development in the Naval Research and Development Director's Office, and head of electronic projects and project development and research projects in Astinave. Captain Ibarra is currently general manager of Astilleros Navales Ecuatorianos, Astinave. Next, Mr. Raúl Eugenio Podetti. He is the author of the book, The Argentinian Naval Industry. He is a naval engineer from Instituto Tecnológico de Buenos Aires. He got his master's degree in science and engineering at Michigan State University. and an MBA at the Business School of Universidad Austral de Buenos Aires. In the United States, he worked in the production of jackups, and in Argentina, he worked in different sectors such as fishing, marketing, and tourism. Since 1976, he worked in the technical offices of Sanin in the shipworks and its offshore area, and he was general director of the company for 8 years. He was vice president of Rio Santiago Shipworks, and for over 10 years was part of the board of the Argentinian Naval Industry Federation, of which he was its vice president until the end of 2017. Next is Mr. Chang Bong-oh, head of a business division at Daesun Shipbuilding Company. Mr. Do is an airspace engineer of the INHA University and a master's in ocean businesses and naval construction of the Maritime and Oceanic University. In the shipbuilding area, he has been production leader, planning and production leader in Sundong, and general sales manager in DSEC. He is currently the leader of the sales division in the South Korean Ship Works Daesun and representative in the cooperation between COLOMBIAMAR and Daesun. Next, we will hand the floor over to Mr. Camilo Fernandez de Soto, who will be the moderator of the forum. Mr. Camilo Fernandez de Soto is a lawyer with a specialization in economics of Universidad de los Andes and a master in public administration from the New York University. He's experienced in the promotion of commercial trade of the country and foment the growth and internationalization of the companies in the region. He was involved with the IDB as a specialist in integration and trade, and also as a coordinator of the Corporate Dialogue of the Americas, an initiative of the IDB in articulation with the private sector to work with the governments of Latin America and the Caribbean to construct a public-private agenda that will drive economic growth. The work of Mr. Fernandez de Soto has been focused on the design and startup of promotion program for exports and attraction of investments in Latin America and the Caribbean. His experience ranges from Ministry of Commerce, Industry and Commerce. He currently works as the president of Colombia Productiva. Mr. Fernandez de Soto, the floor is yours. Thank you very much. How exciting it is to be here with this panel. I would like to thank very especially the National Naval COLOMBIAMAR, the Almirante Padilla Seaman School, and the Naval Institute for the organization of this 7th International Naval Design and Construction, and for having invited me to participate in this panel of the shipbuilding sector as a competitive bid, opportunities, problems, and proposals. And I believe that precisely that is what we will address today. Let me introduce our panel for today. It really is a pleasure to be able to have Admiral Luis Fernandez Marquez Velosa. He is the president of COLOMBIAMAR, the Vice Dean of Universidad Tecnológica del Toro, Frigate Captain Vladimir Ibarra, Diastinavi, and Mr. Eugenio Poletti, whom I met some years back in Manizales, and lastly, also the head of the business division of Daesun Shipbuilding, Mr. Chang Bong. So, a pleasure to be here with you. I have a presentation to begin, which I believe will address that precisely, what has been happening in our shipbuilding sector in the last few years, and why, in fact, it is a bet that the national government has in terms of the opportunities, that we have some challenges too, but some good news, which I think will go well here with the audience, because it's to tell you about a big project that is just about to start thanks to the cooperation and generosity of Korea. Could you please allow me to share my screen? Yes, I have it here. There. Very good. Again, thank you very much to you all. And just to tell you that in Colombia Productiva, we are part of the commerce industry and tourism sector as one of the three entities working on corporate development. And we focus precisely on promoting productivity, quality, the added value, so our companies can continue to advance not only in conquering markets in our countries, but also to be able to compete in international markets. And precisely in this industry, productivity, quality, and added value put the limelight on our work. And that is why we work with that. From Colombia Productiva, we work on 5 axes to help companies improve and raise their competitiveness. We have the greatest impact program in Latin America, and which is tending to companies in this sector. We have knowledge transfer program. And I'd like to highlight something important quality-wise. This industry, certifications of quality does not work. If a welder is not a certified specialist to be able to work on a vessel, he will not be able to then be part of this value chain. So we work strongly in helping companies and entrepreneurs to achieve those certificates. We work on productive chain projects. And just now we closed one big development project for vendors for the shipbuilding sector with the Chamber of Commerce of Cartagena, the Chamber of Commerce of Manizales, working with 55 small companies of this sector and make them ready to be able to engage in working with the over 30 ship building works that exist in our country. We're also working on the cluster strategies. And in the end, I will tell you all that we have for this sector so that it may continue to move forward in terms of its productivity and competitiveness. Now, what has been happening? What are those figures for our country? IMAR tells us that there are 49 companies in Colombia who can and are authorized to work on this sector. So here you can see the distribution, but mainly they are located along the Caribbean coast. 35 of those are ship works and 14 are workshop. You see that Bolívar is the department with the highest number of companies in the sector. And here we show you 2 very different universes, because we see precisely that 63% of the companies work with the construction of ship in fiberglass materials and 37% in steel. This shows us that there is precisely the opposite of 2 very independent paths and very specialized on which our companies work. So here we start seeing that differentiation in the sector. Now, vis-a-vis our export, it is worth mentioning that we had been working at a good pace. We can see how from 2015 to 2019, we managed to show a growing trend in terms of exports. In 2019, Colombia exported $19 million, which resulted in a 34%. 19 million in 2019, but there was a drop of 84% in 2020, representing only 3.1 million. So the pandemic has had a huge effect on this sector. And what we must do is to continue to work, continue to understand our market so that we can then recover that path of growth through our experts by understanding our market. We saw precisely how in 2019, Guatemala took 65% experts in this sector, followed by the United States with 15%, and then the Caribbean accounted for the rest of the percentages. Over here is just to understand that the cumulative of the last 5 years has been similar. United States has been leading, right, as our country of export between 2015 and 2020. with close to a 32% share, followed by Honduras, Guatemala, Panama, Costa Rica. So what we see here is, in fact, that our niche markets are precisely both in the United States as well as Central America and the Caribbean. So we have to work hard to continue to work with our clients and regain that growth. We also see that the Department of Bolivar had the biggest participation with 67% of exports. So it is worth highlighting that those exports were mainly in ships in the defense industry, dredges, lighthouse ships, and vis-a-vis the imports. What did we see? We see that we have a broad spectrum of countries from which we import. During 2015 to 2020, imports hovered around $216 million in 2020. The figure rise to $63 million. We see the participation of Holland, the Low Countries, is very important, with 17%. United States 16, Croatia 15, South Korea 14, China 8. So, and here we see that we are importing mainly the ships for the transport of goods, people, tugboats, and defense ships, among others. So we see here a big potential also to compete with those imports vis-a-vis what we see we have capabilities on. You know, we have seen high quality ships from our shipworks. And what are the opportunities we see? Well, let's start with one of the most important. In Colombia, we have over 18,000 kilometers of navigable rivers. With the recovery of the navigability of the Magdalena River, we are going to have almost 1,000 kilometers of the navigable river, and the demand for barges is forecasted to at least 1,000 when this industry takes off. We also see everything that is happening with the offshore industry, where there are already 5 offshore wells off in the Caribbean, which will also represent an opportunity, something very important that the TLC left us, the TLC with the United States, with the capacity to do repairs. The U.S. flag ships, thanks to the lifting of the restriction that the Jones Act had. So this TLC with the United States gives us that possibility, provide repair services for those U.S. flag ships. Also, this international market of nautical industry, where Cartagena, Barranquilla, Santa Marta, San Andres have an enormous potential to develop this industry. And last, well, the plan in the defense sector with its PES strategy, which seeks the productive transformation to construct those 8 large frigates in our country, in our shipworks. And over here, this is just a comment related to some of the previous points. We saw that, as I told you, the Magdalena River has about 1,000 kilometers of navigable way. A recent study talked to us about the savings, logistic savings that are meant by conducting this mode of transportation, which could represent between 10 and 50% of the transportation cost. So this is very important for our country's competitiveness. We see that in our country, mainly, we could be moving through the river right now close to 72% of containers, about, 72,000 tons in containers, steel, coal, corn, cement. So the important message here is that with this recovery of navigability and with this reduction and the savings that can be generated, we can increase the competitiveness of our sector. And what we have seen is that from the perspective of public policy, the national government has been highly consistent. I see 3 large instruments that have led to the development of the sector. The First is Compass 32, the National Logistics Policy, which promotes the modernization and the strengthening of 295 vessels for the transport of hydrocarbons. Just to tell you that currently our mode of road transportation represents practically 73% through lands, through roads, and 1.5% through the fluvial or river transportation. So here we have enormous transportation to start making greater use of our rivers and then generate those savings that you saw, which, as I said, range between 10 and 50%. We also have the Compass 3930, the Compass on Colombia bio-oceanic power, which seeks to boost those economic maritime activities through the development of the value chain and activities in research, innovation in the shipbuilding sector. And finally, just to mention that the shipbuilding sector was also part of the agreements for the growth of employment. Public-private agreements were executed to close those bottlenecks that were identified in the sector to be able to expedite the red tape, customs agreements. Also, the Prostillero program, we will continue to support all these. Let me tell you about Colombia Productiva. How are we boosting this important sector? I will tell you through our productivity manufacturers. The greatest impact program in Latin America. We have 58 companies of this sector who have participated already and have benefited from this program by improving their indicators significantly. We also have our strategy of quality to grow because we help in training, technical assistance, and in certifications programs, right? Quality to grow. We have a new edition, training, technical assistance, and certifications. And last, as I told you, the production chain project where we work with 55 companies in both the state of Caldas and Bolivar, a program of almost 1,000 or 1 billion pesos where we managed to obtain significant research. We also work with the SENA, where we have a program, Innova Productivity for companies, where 6 companies access that is a co-funding program of up to 200 million pesos. And you can see that we have co-funded companies with over 1 billion pesos. And I'd like to tell you about 2 initiatives that right now are available for all the companies in the sector through our project of Cluster Más Pro. This project, the goal, the intention of this project is to fund projects between 200 and 600 million pesos in cluster initiatives. There are 2 here, both in Caldas and Bolivar. And any other who would like to participate or who could participate, the invitation is still open until September 15th. And lastly, and not because it is the least important, but perhaps the most important, see, because thanks to the good work and the fraternity of with our brother country Korea, through its agency, we managed to secure this year a cooperation project worth $5 million to strengthen the shipworks chain through a vendor development program with $5 million that will start now in the 2nd semester of this year and will go all the way to 2024. We're very happy because we worked at it for the last 2 years. And we finally managed to get this project, which will no doubt help the companies in our country to achieve that sophistication, that quality, those standards to continue to move forward in growing this sector. So this is all that we wanted to tell you from Colombia Productiva. And invite you to look at a video from Deputy Minister of HISEC, who also like to greet all the audience and send a special thanks to the panel members, given the importance the shipbuilding sector has for our country. A very special greeting to the opening of forum of the shipbuilding sector as a competitive bet. COTECMAR is the most important group of companies. This group generates 14.4 billion pesos a year. The importance to centralize these resources and activate the economy. We expect to find employment in Colombia is that we could all have a sense of belonging, and that we may be then we acquire the capabilities required. COTECMAR are leading shipworks in Colombia. We want to generate production change with the private sector so that we may in fact be able to restart the economy. These scale economies, yeah, that's different. And so that we can strengthen internationally so that they may get to know our shipbuilding and our industry today, Colombia, and we represent the insecurity not only with all the technical capacity and all the operational capabilities that COTECMAR gives. This forum is crucial because they will give us the capabilities of Colombia with science, technology, and information, and that transfer of knowledge is vital so that today all Colombians have security and we may be competitiveness, not only nationally but internationally. A very special greetings to all, and the fundamental is to go beyond this place in production change for all Colombians to enjoy benefits.
Gracias a nuestro viceministro.
Okay, thank you, Vice Minister. And again, I would like to send a special greeting to all of our speakers this morning, the Academic Vice Chancellor of Universidad Tecnológica de Bolívar, Mr. Daniel Toro, Frigate Captain Vladimir Ibarra, Manager of Astinave Ecuador, a representative of IPIM, also Mr. Codetti, author of the book on the Argentinian shipyard industry, and finally, Dr. Yahun, Manager Business at Dyson Shipbuilding CEO. Okay, good morning, everyone, and thank you for accepting this invitation put out by the International Conference on Naval Design and Engineering. And I would like to start by asking a question of the Academic Vice Chancellor of Universidad Tecnológica de Bolívar. What can you tell us on the basis of the economic and technological impact achieved by Universidad Tecnológica de Bolívar? Which do you think are the key factors in the evolution and the dynamics of the shipyard industry in Colombia?
Perfecto, sí, muchísimas gracias, Camilo.
Yes, Camilo, thank you. Okay, good morning. Thank you so much for the invitation. It's an honor to share this event with you. And as you've said, from Universidad Tecnológica Bolívar, we have been working on a collaborative basis as of 2009, if my memory doesn't fail me, by monitoring the activities of Colombia's main shipyard, COTECMAR. We have worked very closely to try and determine what are the general impact points of COTECMAR's work in social and economic regards, all of the influence of COTECMAR, the sector-based influence, and the results are quite significant. You were detailing the sector dynamics, and there is an important challenge and a factor to consider, which has to do with this exercise that we have been doing from 2009, and it has to do with the measurement of activities, because it's sometimes difficult to frame in an appropriate manner all of the activities, particularly within an institute such as COTECMAR, and generally speaking, an industry with such a heavy innovation component. And in that sense, and just to mention an important detail, of what they've been doing in order to measure the relative contribution by Cotecmar to different sectors according to what we wish to observe. There are different possibilities. We, of course, have seen it within the shipbuilding and ship repair sector. It's contrasted the field of experimental research and industrial design and this industry motion, and that, of course, generates different versions of the same story, all of which are just as enriching. And within three of those four industries, Cotecmar actually contributes with about 70% of the sector and operational income. Cotecmar accounts for over 2/3 of what is being developed in those sectors, except for industrial design. But for instance, as for industrial design, where there are so many companies, Cotecmar has a trajectory of over 17 years and is one of the companies that contributes most in terms of income. And by 2020, Cotecmar was the company with the highest level of contribution. So there are different elements that lead us to observe that the sector and Cotecmar particularly play a significant role in the local, regional, and departmental development. Another aspect I would like to highlight in terms of what we have measured with a methodology that we've developed and polished over time through our team, through the joint work between Universidad Tecnológica Bolívar and Cotecmar, we try to determine how to measure this spillover effect of Cotecmar's activities around those aspects, social, economic, but also technological, and what we have known in international literature as spillovers. Is interesting to see how not only the sector, but also Cotecmar actually drive in a significant manner the earnings generated within the sector, locally, regionally, and nationally on the basis of its productive activities. So Cotecmar's productive activities, its technological breakthroughs, and the human talent have a positive effect, and that spills over to other activities with an impact not only on sector companies, but also within other sectors with which Cotecmar holds relationships. And there is another element here. There is a productive chain within the sector, generating a potential for job generation. So there are many, many significant factors that we need to take into account. There are other benefits, the geographical location, the characteristics of the city, the potential that we have towards productive transformation, and some elements which are still to be developed, but which are sitting there, which have not been consolidated yet, but which will play a significant role within the industry, no matter our perspective, from the perspective of innovation, from the perspective of construction repair, and from any other perspective that we may adopt within this issue. Okay, Daniel, thank you so much. And now I would like for both engineer Vladimir Ibarra as well as Raul Eugenio, and at the end, you as well, can tell us a little bit about your perspective. What do you think are those opportunities and challenges being faced by the shipyard industry? And Vladimir, if you will, let's start with you. Okay, good morning, everyone. I'm very pleased to participate in this forum. Your invitation was so kind, and it's always an honor to be talking to Colombia and to be participating with anything that has to do with the Navy. And I was actually privileged to have been trained at the Almirante Padilla Academy. As for the challenges, we need to frame that within typology of activity from a perspective of what is going on in Ecuador. With regards to ship maintenance, and later on we will look at shipbuilding. the opportunities, at least taking into account the realities of the Ecuadorian maritime fleet, the demand for maintenance solutions is going to step up. Why is that? Because we're talking about different types of vessels, fishing vessels, a significant fleet within the cargo carrying industry, tourist industry, and so forth. In all of these sectors, the trend is for vessels to be seen as year-long units of operation. When those units came to our country, some of those units had been decommissioned in other nations. And of course, those units have to be overhauled extensively. So from the shipyard business perspective, us being the ones providing maintenance, be it revamping, overhauling, or even reconstruction, that or refurbishment, those demands are getting ever higher. And one of the drivers of the shipyard industry is the fact that it's very profitable. So that allows for shipyards and their economic fabric, as well as the supplies requiring this activity, may make their participation more dynamic. Their work becomes more dynamic. There is a lot of asset circulation. More people are engaging into a sector. Technical levels climb higher. So at least from the perspective of Ecuador, the demand for ship maintenance is going to climb even higher due to these requirements. Now, what are the challenges? How do we add innovation to this industry, which is well positioned and highly traditional? For instance, a shipbuilder who gets a proposal for replacing some of the unit systems by this other system, it's expensive, but you're going to be able to achieve savings over time because your operation is going to be more socially responsible, is going to be more environmentally sustainable. So the most important challenges lie in the fact that we can provide shipbuilders with better service, but they have to offer their acceptance. That from the side of maintenance. Now, as for shipbuilding, the opportunities are connected to those realities. I'm talking from the perspective of Ecuador, and I guess it's very similar to the rest of Latin America. I don't think it's that much different because we're going through basically the same realities. Since we don't have any clear data from other countries, I cannot speak from certainty, but it can be extrapolated because it's a very similar reality. Huge opportunities lie in the building of new units as long as shipbuilders are ready for the building of new units. If uh, building new units generates benefits in terms of time, they don't do so, they still don't do so. They get second-hand units and they simply revamp those. As a matter of fact, all of these stakeholders are in the industry and they are there because they are good at making feasibility studies and the benefit that they are going to glean out of it. So it's not very appealing, commercially speaking, at least not in Ecuador. Therefore, there aren't that many possibilities there unless the regulation changes. But not just that, these are powerful sectors. They wield a lot of influence. And of course, they are not going to be allowed for anyone to impose rules on them. The regulation has to incentivize so that there can be opportunities. However, in reality, real opportunities in shipbuilding are in the defense sector. The ones that truly build and the driver of growth is the Navy, just like in Colombia. And the opportunities reflect innovations leading to products customized to operational capacities and the economic situations. The project can be wonderful, but if the country cannot pay for it, it's not going to materialize. So those are the opportunities for innovation. It's like the multi-purpose vessel project that we are managing right now. with Astinave, we have proposed the Navy to generate a multi-purpose vessel which perfectly fulfills the operational needs of the Navy adapted to our realities and which is something that the country can pay for. This is, as a summary, what I can contribute. Thank you. Okay, Vladimir, thank you. And yes, I believe that here in Colombia, we have this additional challenge. And as I was telling you at the beginning, we still have a low level of maritime and inland waterway participation. So the opportunity becomes even bigger on the basis of the demand which is going to be generated. So I believe it is a good wager for our sector. Okay, Raul, how do you see this from Argentina?
Ahora sí. Quizás es una premonición que no tenemos demasiado para contar.
Maybe this is a premonition. Probably we don't have that much to tell from Argentina. Okay, as a matter of fact, beyond any jokes, all jokes aside, every time I look at Colombia's breakthroughs and after what Vladimir has told us regarding Ecuador and the examples from Chile, from Argentina, my first sentiment is that of envy, and not the healthy kind of envy, but the worst of envies when I look at attitudes, long-term government policies, which are the ones that truly provide the continuity that the industry requires. So, first off, I would like to commend you guys for the support that you're providing to this industry, which can only have a future if there are long-term policies such as the one I see here in Colombia, whose case I follow up on very closely in this whole race that started off this century with Cotecmar, as well as all of the other shipyards who have engaged the industry. So specifically referring to the challenges and opportunities, the first thing I can contribute with is that we, the shipyards, the naval engineers, were not that much different from the rest of earthlings. So our challenge have to align to the challenges of the remaining inhabitants of this planet. And what is the challenge that we face today as mankind? Okay, the biggest challenge revolves around climate change. We cannot set aside, as the ones in charge of the naval and technological issues, this pressing issue of climate change. And particularly, of course, I would like to make this contribution so that our actions, both from the government as well as from the private sector, academia, as well as personal actions, every single one of us needs to align with our humanity needs regarding climate change. I'm referring to two different types of actions that we can work on. Clearly, one of the actions have to do with mitigation and others have to do with adaptation. As for mitigation measures, our efforts will never suffice in order to achieve energy transition so that we can exert a lower impact in terms of carbon emissions and other deleterious effects on the environment. That is a task that we from the naval industry and naval engineering have to take as a challenge, and we need to invest resources into it so that we can achieve the objectives. And the other side is an adaptation to climate change. What are we doing to change what we know is going to happen? It's not surprising for anyone that we're going to be getting a whole lot more droughts and floods and so forth. So, what are people around the Magdalena River doing to address the low draft of the river? What is being done to avoid situations such as those experimented in Chile with the tsunamis? So adaptation as well as mitigation, our shipyard industry and the naval industry, we have a lot to contribute to reduce impact and to adapt to this impact. But this issue of climate change is not just a challenge, it is also a giant opportunity, and particularly for us, designers and shipbuilders and also those of us who refurbish ships. Vladimir was horribly clear on one of the biggest problems that I believe we face in Latin America with regards to our naval industry, which is precisely the floods that we have seen in settings with obsolete navies, imported older ships, the use of second-hand obsolete ships has been incentivized in Latin America. So how can we ever become competitive
en la defensa,
in Latin America in terms of defense or transportation if we are based off of using units that truly competitive nations have disposed of, probably because they are not useful anymore or because they are highly polluting. And that's the whole disposition of these types of ships. But how does this connect to the issue of climate change? There is no market for obsolete vessels based on clean energy. So we have a new opportunity. We in Argentina and Mercosur have seen this very, very clearly. Of the 2,500 vessel units that have come in from the 90s to our waterways in Paraguay, the vast majority are basically discarded units because they contaminated the Mississippi River on an excessive basis. At least in terms of engine-driven vessels, this is going to change because ever more vessels with cleaner, more efficient energies will be required. And those vessels have to be built. We no longer should import those units because it is a non-existent market. Therefore, that generates an opportunity. But for the opportunity to come to fruition, the biggest hurdle is not technological, it is not a lack of capacities or knowledge, it's just financial, as Vladimir was recently pointing out. The business, the business is better for shipbuilders when they are allowed to exploit a substandard or second-hand vessel. But that's the key of the funding part of this. If the funding is smooth enough, the convenience of a new vessel, of a more competitive vessel, changes the whole equation of the Navy. And there we have two sources of funding, which are very important. First, the one is related to climate change, which is green funding. Is the type of funding where external money from Europe, from Asia, and from multilateral banks actually come in, and they contribute to projects or to countries so that structural positive changes with regards to climate change in our regions can be implemented. This is a specific opportunity for working out the problem of climate change and the social development that we're trying to build up in our countries. Now, lastly, and commenting Colombia's relationship with Korea in terms of their involvement in the productive development of the Colombian shipyard industry, I would like to make a suggestion to the remaining countries of the region. Let's always look, very attentively look at the external naval groups that we have a lot to receive from and that we have a whole lot more to give to. The access to our markets no longer is driven by the purchase of ships, but rather through the purchase of those parts that we still don't manufacture so that we can integrate those into our processes and so that we can build ships with those technologies, with their funding, but with a higher technological component and also in terms of labor in our countries. Thank you. Okay, Raul, thank you. And I would complete that last sentence that you uttered. And we should also send them the parts that they're not interested in producing anymore so that they can incorporate those into their um, supply chain. Okay, Raul, all of your points are very, very relevant. And one of the things here in Colombia is that since we arrived a little bit late to this debate about the recovery of our navigability, all of these challenges that will be imposed by climate change undoubtedly have to be part of those projects. If we provide the Magdalena River with the engineering that was imagined 10 years ago, probably it would be obsolete in the face of all of these new challenges. The same goes to the dry docks that we have. So there is a huge opportunity in arriving late to this discussion, probably because our public resources and our investments had to be tailored for other purposes. These days, those projects have to think big because what we're seeing right now is challenging. Now, some of the departments of our Caribbean coast are going through a lot of floods. We saw it back in New York, a city such as New York getting flooded, despite the fact that it has all the resources in the world. And looking at New York streets totally submerged, that leads to a debate. And you were talking about this green funding, the concept of green funding, which is the big opportunity for those projects as well as for our shipyards or our sector enterprises. And to link to something you said, Sergio Díaz Granados, the new president of CAF, the Andean Corporation of Promotion, came into office, and one of his objectives is going to be funding for green development. So that's a very relevant message. So Raul, thank you so much for your for all the points you made, and I would then continue with Daniel. Okay, Daniel, how would you close off this chapter that we saw in terms of opportunities and challenges? Okay, Camilo, no doubt, two elements that I would like to add to what the previous speakers have said. One has to do with the growth opportunities in terms of foreign trade. There we have an important challenge, but also an opportunity. It's been pointed out many times before by different studies. Jorge Garcia, who's a well-known economist from the World Bank, he's done work to identify what's going on with foreign trade in Colombia, and their conclusions are very disheartening because his findings show that precisely in Colombia, there hasn't really been an expansion of foreign trade. And in that regard, as long as we don't have a real breakthrough in terms of foreign trade, the possibilities of the sector are going to be very curtailed. In this sense of the capacity that we may develop in order to move forward, most of our production is going to be limited to the fleet that we have now. And we can only expand so much, but we cannot go full potential. And that is closely connected to the reinforcement of productive chains. On a domestic basis, we saw it from Universidad Tecnológica de Bolívar, also all of the work that we've done with COTECMAR by way of an analysis on the PES, the surface strategic platform. And one of the concerns is how strong supply chains can become domestically, despite the fact that many of those supply chains are not ready for these kinds of huge challenges. So we need to continue doing this whole exercise. We have to move on with these productive plans so that we can strengthen and advance something that's been a huge contribution in the past few years, namely measuring the participation. And Professor Ricardo Hausman from Harvard University designed something that is called the Economic Complexity Index. And that index focuses on looking at how much added value comes from each productive activity, as long as they are combined to other activities that generate more added value within a single geographical region. And there is a lot to do in terms of moving forward with economic complexity so that we can offer products and services that can better adjust to the shipbuilding, ship repair activities, and all of the different activities that generate so much value within the national industry. And in the case of COTECMAR, in the past 20 years, it's been one of the companies with the biggest contributions into the economy. So we have to give this the relevance that it has so that we can drive forward not only COTECMAR, but the industry at large. Those are the elements that I would like to point out regarding growth opportunities on the basis of foreign trade and the reinforcement of national chain supplies. Okay, Daniel, thank you so much. And now I would like to welcome Dr. O. Dr. O, thank you.
You here. Para todos los que nos ven, Corea, ustedes saben, es
For
un
all
país.
of us who are seeing us from Korea, as you know, it's a leading country in this whole sector. And Mr. O is the head of division of Daesun Shipbuilding, and they are an important point of reference to see how we can advance, how we can move forward. Okay, Mr. O, I wanted to ask you a couple of questions. The first one is precisely what has been the role and the initiative that the government has set out for the development of the sector, and how do you think our government can move forward through this moment, through this day and age, so that we can push the shipyard industry forward? And the second one is, what are the policies or regulations of the Korean government that have impacted positively the shipyard industry in your country? And at this point, what do you think is missing? Because today's industry is not the same as many years ago. So what do you think we should replicate, and what direction do you think we should move forward?
Hello, listen well. Everybody say that good morning, but I'm saying that good evening. Right now is is midnight. So I am Mr. O, is work on the business division on the shipbuilding industry. But firstly, I very briefly introduced our company. Our company established in 1945. Is at the time it started very iron works, but and then the 1960 and 1970 at the times we worked the ship repairs. Is the fishing vessel and the small commercial vessel. As at the times we started in 1970 times we shipbuildings very small size commercial vessel at the bulk carriers and the passengers 1,020 200 persons. But it's my honor to invite such a very important event, and then I think it is happy to get the business chance with Colombia. But through this meeting, I try to grab the currently status mode currently to be some help to the Colombia ship business and to progress with the business for the development between the two countries or the two parts. I answered, I think the role of the Korean government in the development of the Korean shipbuilding industry should be divided as three periods. And the first time is it was the government lead the period of the processing heavy and chemical industry. Almost I think it is 1970 times it started. Was the activity support was provided for the basic of the industry by the arrangement of large scale government funding. And the foreign funding is below for the shipbuilding industry. Here, a lot of the capital was initial investment times. So that they tried to do almost 20 years. And then during the growth period is almost, I think, the 1919 times, the private shipbuilding company, they have some competitivity within the world shipbuilding market. At the time, they try to how to grow up the productivity. So they connect and the cooperation with the Japanese shipbuilding industry. At the times, Korean shipbuilding yards, they wanted to how to do more grow up the productivity, and then there's some more the detailed technology part. And in the short times since the Koreanization is a Korean unique intensive rush temperature and the explosion of the period of the shipbuilding and offshore industry received the world. And I think it is 2010 and then 20 at the times. Recording the design, product, and quality, and become the world best shipbuilding industry times. Accordingly, it appears the Colombia government should be consider establish the policy for the shipbuilding industry in connected with the own shipping industry. I believe that it should be the absolutely necessary to identify the vessel leader in the country or the neighborhood Caribbean Sea, define the ship size to the necessary technology of the shipbuilding industry suitable for it. Establish the feasible step-by-step is important, I think. Check the performance based on this, the provide continuous policy supported almost, I think the 20, I don't know exactly, but it is, in any case, is different. In particular, it's necessary to pay the attention to the global environmental status and to think that should be bolded eco-friendly policy and the safety work environment management in shipbuilding industry part, I see. Okay, thank you.
Muchas gracias, señor O. La verdad creo
Thank
que...
you, Dr. O. Okay, it is very relevant. Your perspective is quite relevant, and undoubtedly, that technological focus that we have had can be highlighted in terms of productivity, which is essential. Something very important that you were saying is the generation of stability and to be able to generate long-term policies. That's what in Colombia we've been doing by means of an instrument known as COMPAS, which is basically a long-term policy that recognizes the importance of this factor. And of course, the development of providers, which is essential, as you mentioned, and with the cooperation project that we will set up, there's going to be a transfer of knowledge and technology from you, which is going to be paramount in this effort. I would like to ask you an additional question, given the fact that as an interior productivity, we're always trying to measure everything. I wanted to ask you precisely that. Okay, what do you think can be a good proposal to improve the indicators of productivity and competitiveness, as well as sustainability in the shipyard industry here in Colombia, so that we can keep that in mind when it comes to doing our work in our COICA project and other projects as well?
But I think the future is very positive because the currently Colombia shipbuilding industry, they have the related to the characteristic of the country, and the vision for the development is will be established and then very strong. So, and already discussed, everybody say that the early sentence when the Korean shipbuilding industry sought to secure their own visibility and the competitivity. Various policies were, implemented, including the tax benefit, funding, training for government leading production training programs for the training part is very detailed. And then sometimes some part is welding, and then the scaffolding, and then pipe production, and painting, and grinding is very detailed. And then at the first time, the government should be the support to that part is very detailed. And then labor cost support to the training is some shipyard they have done enough to some payment for the labor cost, but at the times the government should be addressed as something. Those policies should be implemented and like to be in Colombia to value to develop the shipbuilding industry, I believe it. In particular, training center for the production technology is the most important as the cause of the shipbuilding. The training center almost the expansion, but I think there is someone said they are training the only shipbuilding industry training just like this, but they have some limitation of their work. But I don't know what it's just like that. But they training in shipbuilding training centers, and then they use another shipbuilding, another industry, just like the civil work and then the machinery part. And then I think it's there. So the recently development electric shipbuilding technology. At the times, it is the usable, the combination, the training system is more important, I think. That. Thank
Gracias.
you.
Gracias, señor O. La verdad que creo que muy al lugar.
Thank you, Mr. O. I think it's very appropriate, and we make great efforts because, just like you say, a welder who is not a perfect welder, or a painter who does not do his work correctly, they will not have, unfortunately, a place in this industry, which demands so very high standards of quality. So it is true that we need to work on these training policies strongly, particularly for this industry. I would now like to be able to ask you, or ask Vladimir, as well as Raul, as well as Danielle, thinking into the future, what is your view on what those actions should be that actors should carry out in this shipbuilding sector? Let's start with Vladimir. What are those next steps? Well, in the first place, having understood who the actors are in this industry, the actors in the sector, obviously we require long-term, short, mid, and long-term policies. I think that they should be pragmatic policies, and not philosophical statements that in practice will not be feasible. For instance, what I said in my first remarks, we gain nothing with having a wonderful, great idea if the financial conditions of the country will not make it possible. There will not be productive training in our countries, that is in our region, if there is no sustainable demand. So policies must be not only good intentions, but they must also be realistic. And by being realistic, you need to take into account the mid to long-term financial conditions, because there are wonderful ideas, just like Raul said, that it's not a matter of a lack of capacity, because the welder is trained and the welder will be qualified. The problem is not there. In this company, in this set of companies, we have the operational capability, the install capability, the organizational capability deals with people and processes, install capability with facilities, machines, tools, hardware, the software that we need to use. All that is developed. You can develop it. It is just a matter of organizing oneself and having a heading. But what you cannot do is to force the actors who will demand the product and services to buy those solutions and goods and services, because they also look at their reality and they define their actions. And it's not about imposing, because like I said, every ship owner will be forced to change their ship in place of eco-friendly ships. They're not going to let themselves be imposed on, so there should be a balance. We need to proceed intelligently. That's the first. Those of us in the industry, the producers, in this case, the shipbuilding companies who are integrators of solutions, who require vendors, national vendors and foreign vendors. Korea is a very particular case in other countries who are practically verticals. If you want to build a ship, Korea can build it with its own national production completely. They produced almost everything, but that is a reality that we don't have here. And no doubt we will need to bring technology, raw materials, and intermediary goods from abroad. And anything that we may be able to do in the country, we need to drive it, to boost it. Anything that is in the country, we prioritize it. Perhaps at the beginning, it won't have the quality or the standard. And, if they don't start producing, if nobody will invest on anything, if no production is to be made. Also, in time, we need to incorporate technologies. And when we talk about the install capacity, we are talking about data center, hardware, software, whatever modality, on cloud or on premises, that will allow us to implement philosophies that integrate product engineering, production engineering, that they be susceptible of being integrated into the logistics chain, something that vendors cannot do perhaps independently, but by the shipbuilding or integrating companies such as our academia must provide support. The universities must be more pragmatic, more oriented. In Colombia, given that the Naval School is the only university with the naval engineering career has fared better. Here we have the Polytechnical School and the rest of the universities, but there is a distancing between academy and industry. I see it, there's a big gap. In industry, we need to be pragmatic. In school setting, they often are very, I'd like to be clear, I'm being honest. What I'm trying to say here, without making any offenses, I see that sometimes the academy focuses on philosophical aspects. You know, academic action is good for their setting, but if not practical, not pragmatic, and I am talking about our reality. I am not talking about what happens elsewhere because I don't know. But the other matter is with respect to knowledge. We have to define very well, I believe, what should be proprietary, what should be open, what should be knowledge that we share. Because like Microsoft, who was released many of its applications as open source because they saw that it was an opportunity to gain more knowledge. We have to do something similar, particularly because it's not like we are such a huge base of knowledge, you know, patents everywhere in our country, you know, we need to protect the inventions. No, I believe we need to be integrated, and we need to integrate as a block because individually we are very small. We are tiny when compared with the global context, and in the global context, our specific weight is practically negligible. And if we want to have an opportunity, I believe that individually it is hard, but now that also depends a lot on our idiosyncrasy, because each of our countries is in the same, is after the same thing. We do it here, we need to do it here. And if Colombia has something, then I'll do it just like Colombia, for instance, integrations so specific for the production of line ships. Colombia has made strides, Peru has made strides. Have we integrated into practice? Have we? No, it's all discourses. You know, things that are said because of protocol, but which in practice do not conclude in an integration, in a real integration. And we need to be very clear. Do we really want to organize ourselves? And we need to start inwards, obviously. But if we want to have weight internationally, we need to share knowledge. We need to open it. We need, that goes hand in hand with the technology transfer. You know, certifications, I don't see that as a problem. A welder, an unskilled welder, you train it and that welder is skilled, there's no problem. It's more about organization, more about technique. It's not in the capacity to execute, but in the capacity to organize what we have. If we are able to overcome that, Simon Bolivar wasn't successful with Gran Colombia, and since back then things were bad, and I don't think things are simpler today. But I believe that the way to foment that is this way: first, clear policies, pragmatic policies, not philosophy that cannot be taken to reality. Then real opportunities based on real funding. What we can do? Fine. Regional integration. You have greater development on that. Colombia, fine. Colombia, strengthen on that and then give it to Ecuador. Ecuador is strong on this, fine. Do it, Ecuador, and then give it to Colombia. And the last, you know, integration of technologies, PLM type platforms integrated with ERT, where we can innovate and share that knowledge as an open framework. That would be a very quick synthesis of what I believe could be done, pragmatically speaking, that is. Thank you. If I may, no, I just wanted to avail myself. to say that Professor Ibarra was talking to us about these challenges in the academy. And I agree. I believe the academy needs to take a more proactive role. And I wanted to mention some aspects of what he commented that we are developing at Universidad Tecnológica de Bolívar. The first is to say that Universidad Tecnológica de Bolívar in Cartagena is the only private university that offers naval engineering ever since 2016, in addition to the Almirante Padilla School. And that is good. That's good news, just so that he knows about it, because we are already graduating our first cohorts. We are working closely with different ship works. So Vladimir will gladly invite, receive you here so that you can know our program. And we have a doctorate program, and of which one of its work lines is associated to that. No doubt, because we are conscious, like you say, Vladimir, historically, Colombia and perhaps several countries in the region, we have a lot of debt with respect to the maritime and fluvial development. And in this sense, we are getting up to date. And we are sure that by betting on research and innovation, that will be the key. And that is why we are proposing interesting things. For instance, we are leading here in Cartagena the canal channels and lakes project, because Cartagena is surrounded by usable lakes and channels, and they're not being used. Whereas elsewhere they are artificially constructed. We have them naturally, but not use them. We are designing, for instance, we have had many conversations and progress on very interesting project plans. For instance, solar-driven vessels for public transportation in a pilot project of a segment that we have channels and links, that those are topics that, of course, go beyond the institutional area. Regulations are always convoluted. They imprint a lot of noise in projects, and we need to make progress in that sense. In terms of competencies of the different institutions in different areas, that needs to be resolved. And something else, vis-a-vis foreign trade, we have seen that we have replaced tariff barriers with non-tariff barriers. And we need to dismount all these permits and licenses, because we need to facilitate trade, especially for a sector that depends so much on that trade, both regionally and internationally, as is the shipbuilding sector. And in that sense, I just want to make those comments. Camilo, Vladimir, apologies. No, thank you, Daniel and Raul. Do you have the honor of closing in telling us about what your vision is for the future, what we should do as a shipbuilding sector? Your mic is muted. I'm not going to tell the same joke, but I will use a simile, which is very proper for an Olympic year, as is the one that we are in today. Now, to talk about competitiveness and looking into the future, as we are mentioning now, in the naval industry world, I propose to look at, and again, using sports, the export of a ship or any good is the Olympic competition. It is there where you truly know what competitiveness there is, or there is none. So it is there. That is when you know when we have competitiveness. So we need to point the torch there, not just to measure ourselves against others, but mostly to measure ourselves against ourselves, because that is the true competitiveness of progress. How we are today with respect to what we were yesterday, and with respect to this sport likeliness, I have to say that no Olympic sportsman or woman was born being a gold medalist. They developed through many years Some had more capacities than others, but ultimately, their supremacy, the world supremacy, had a lot to do with hard developing work. And in yesterday's conference, I said that precisely industrial competitiveness as opposed to competitiveness in the exploitation of natural resources is artificial. The artificialness is inherent to industrial activity. Artificial comes from Latin arti, which talks about precisely the work, the creative and hard work of man through time. And it explains to you why the Asians, specialists in hard, long, creative, and continuous work domain, dominate the industrial market, particularly the naval market. And it is not because they have, and we could ask our Korean friend, what is the natural resource so that Korea is the world naval power in the world? It is in the Koreans. It is in their hard work. And that is why I say one of the characteristics to navigate, to get to the international competition, is continuity in developing hard work. But nobody starts by being in their first race. They don't start at Tokyo 2020. No, before they had national competitions. I'd say in their neighborhoods, in their schools, they first started little, that is, it is necessary for our naval industries to be internationally competitive. It is necessary to strengthen and to become competitive, but locally, within the local market. And that is a very important task that molds an athlete from when he is little until the time he can go and compete at the Olympics. And also in the Olympic Committee of Colombia, Ecuador, Korea, Argentina, surely they don't sit down one day and say, oh, look, we are going to compete in all the disciplines. We're going to be the best in swimming, the best in high jump. No. Certain areas of competition are chosen where the resource that will be assigned specifically, because resources are not infinite. So it's just some areas. The same thing happens in the naval industry. We Argentinians are not going to be competitive building any kind of ship. Neither can Colombians, much less the Brazilians or the Venezuelans or the Chileans. Each one of us, and among us all, there are several items, or actually sport disciplines, wherein we should become special or specialize ourselves. For instance, in our case, fishing and river transport. Also with Chile, we have an opportunity a gigantic opportunity to specialize in the Antarctic logistic sector, not only with the large logistic ships for the armed forces, but also services in the Antarctic logistics from our closest ports to the Antarctic, right? To provide repair services, maintenance services to logistics ships. Brazil proved it in the first 15 years of this decade with the offshore industry, with a gigantic development, and it generated a very specific capability. I mean, they could compete in the offshore Olympics. Brazil could. Also, the constructions of the offshore patrol vessels, where no doubt Chile is leading in Latin America, but where most of our countries should take our place, because it is also the niche within the defense world that is the most accessible, the closest that we have in terms of native industries in each of our countries. So to organize this Olympic campaign that trick is to choose the discipline. We're not going to be good at everything. And lastly, there's another aspect, which is the aspect that I refer to as the most, well, collaborationist. We can help other athletes of our same country to win gold medals instead of bronze medals. What do I mean by this? Well, in the naval industry, we just presented a paper on experts where we proved that Argentina has gigantic opportunities to add value in their agricultural products and their fishing products, for instance. But to the extent that ships, where that transportation that dredges the canals for products to travel, the ships that capture those fish just for exports, that those ships be built and designed in our countries. What that is doing is increasing the national added value to those exports. That is, we are increasing the component, the national added value component in the export, which is not a ship, but because we use national ship, we are exporting more national value. Because ultimately, what do we care? Export 100, if 90 are imported, and then what we are actually exporting is 10, or that are those 100 that we have more and more national components. The naval industry has a lot to do in helping exports, not only ship-wise, but grains, fishing ships, bulk ships for grain. Okay, so what about the medal count? What do you put there? The name of when we talk about the medals, do we talk about the athletes? No, we talk about the countries, because it is the flags of their countries that they represent. So it is not we who make the exports, because an export is a demonstration of the competitiveness, national competitiveness, wherein you need intrinsic competitiveness by shipworks, but also of an entire competitive environment and of the decided support of the state and our government, again, through policies of state. Thank you. Thank you, Raul. And I end with where you again close by stating precisely that in Colombia we have a decided long-term bet to accompany this sector. We use these spaces to take with us your reflections, Daniel, Mr. O, Vladimir, and to continue in our continuous improvement process. Because for us, precisely by betting on this sector with enormous potential, it is a long-term bet. And from Colombia Productiva, we thank you for your reflections. And again, thank you to the Navy Protect Mr. O.
Finally, very shortly, something say that we get the experience about the ship repair and the small size shipbuilding, and then the rest the 5 years ago we are the support to the Peru shipbuilding shipyard, and then we are the support to the engineering and procurement and production parts that we support that. And then we are another country is Indonesia, is PT Power, and then the Philippine shipbuilding some company. And right now we are discuss about the COLOMBIAMAR with the floating dock shipbuilding by themselves. And then we are engineering and then procurement, and then how to the very details the production element is something the technical part. And then we are the very open mind, and then you have something ask something about the engineering part or the procurement part, and there's something just like this. And then right now we are discuss about the koi car with a very good solution. I believe it is a shipbuilding industry, how to do development and how to the movement. It is I think the first is the suitability, and then feasibility, and finally adaptability for each country. And then someone said is okay, very short time, so we are talking about something, and then the technical support. You reach just like the Korean shipbuilding conference. But I think just like that, I think is very important is the adaptability for each country. And then we are prepared all just like this. And then ask something, we are trying our best to your country and your company. Thank you.
Thank you very much, Mr. O. Good evening to you as well, and thank you. Y muchas gracias a ti por tus comentarios y recomendaciones.
Thank you for your comments and recommendations. Very pertinent, and I believe an inspiration with respect to what we have discussed here, the importance of the skills, to know what we have, how to strengthen it, and then use this good news of the cooperation that we have with COICA to move forward. Again, thank you very much. More than 70 people online. Special thanks to everyone, and just bet that Colombia Productiva will continue to drive the strategic sector. Have a happy day. Good day. So we thank all the participants on the forum for their appreciation. From now, we will www.colombiamar.co.
Que se encuentra en curso según el horario y presionamos el botón verde. Si considera, puede cambiar el idioma de la conferencia seleccionando la opción en botón inferior que dice español y cambiar a inglés o viceversa.
Buenos días, señor Juan. ¿Me escucha?
Sí, señor.
Listo, ¿puede compartir su presentación, por favor? Buenos días, ¿me escuchan? Modo presentación, por favor. Listo, señor Omar. Nosotros le damos inicio ahorita para que usted pueda darle apertura a la sesión.
Quisiera verificar si el audio y el video está adecuado.
Sí, ya te estamos escuchando bien, estamos bien. Ok, listo. Entonces,
Vale.
en 3, 2, vamos al aire, señor Omar.
Gracias, buenos días a todos los asistentes por acompañarnos en esta primera parte del segundo día de nuestro Congreso de Diseño e Ingeniería Naval en el año 2021. En este segundo día, pues vamos a hacer un cubrimiento de algunos temas especiales en el área de la ingeniería naval y en la construcción naval. En esta primera jornada vamos a tener la participación de 3 ponencias, la primera de ellas a cargo del teniente Juan Manuel Valderrama de la Escuela Naval de Almirante Padilla. El teniente Valderrama es ingeniero naval y profesional en ciencias navales, y como oficial de la Armada Nacional se desempeña como jefe de división en el buque hidrográfico multipropósito ARS Caribe. Su ponencia se titula Estudio, maniobrabilidad y comportamiento en la mar del buque de apoyo logístico y cabotaje liviano VAL-CL. Le cedo la palabra al teniente para que realice su presentación.
Bueno, muy buenos días para todos. Me presento, soy el teniente coronel Valderrama Juan. Voy a poner mi presentación de la siguiente manera. Se llama Estudio, maniobrabilidad y comportamiento en la mar del buque de apoyo logístico y cabotaje VAL-CL. Los miembros son mi compañero David Naranjo, José Muñoz Ortega y el doctor ingeniero naval José María Rivera Rodríguez. A continuación está la tabla de contenido que vamos a llevar, donde vamos a dar una introducción, vamos a llevarla a través del problema que se nos presentaron, la metodología de cómo desarrollamos todas nuestras dudas y el análisis de los resultados que obtuvimos. La introducción principal es la siguiente. Para nadie es un secreto la riqueza hidrográfica del país. Actualmente Colombia cuenta con 43 ríos principales, de los cuales se subdividen una cantidad innumerable de afluentes. Esos afluentes son la única vía de acceso para poblaciones en esas zonas remotas del país. Paralelamente, la Armada Nacional, cumplimiento de su misión institucional, se encuentra con la tarea, con la dificultad de acceder a esos sectores, porque existen obstáculos de navegación o condiciones de aguas someras, de baja profundidad. Esas son las dificultades para que una unidad pueda transitar sobre ellas. Partiendo desde ese punto de vista, COTECMAR, con alianza con la Escuela Naval de Cadetes Almirante Padilla, gracias al Fondo CAS de MinCiencias, desarrollaron el siguiente proyecto: el buque clase VAL. Lo expliqué ahorita, es el buque de apoyo logístico y cabotaje liviano, que actualmente es muy importante hacer énfasis en esto, se encuentra en fase de diseño preliminar. Se han hecho diseños virtuales, pero más o menos esta es lo que estamos desarrollando y eso es lo que se ha iniciado dentro de su fase de diseño preliminar. Actualmente el buque contaría con las siguientes misiones principales, por ejemplo, operaciones de soporte logístico, ayuda humanitaria, atención de desastre, y ligada con la tercera misión, una atención rápida y flexible en cualquier momento en lo que se requiera. Pero además de eso, no hay que olvidar que eso es un buque guerra y que aún sigue teniendo una capacidad de modularidad. En cualquier momento puede tener cualquier tipo de misión que se le pueden poner. Sus áreas de operación va a ser la zona fluvial y la zona costera. El problema en sí lo basamos de la siguiente manera: ¿cuál será la capacidad de maniobrabilidad y comportamiento en la mar de un buque tipo BAL-C al tener una forma de alto coeficiente de bloque y un calado muy pequeño? Entonces, a partir de esto, iniciamos todo lo que era los estudios de maniobrabilidad y comportamiento de la mar por las características que iba a tener, o los que creemos que va a tener en ese momento. Las zonas de operación iniciales del buque, tenemos la dividimos en dos zonas: la zona litoral y la zona costera. La zona litoral que escogimos nosotros fue el río San Juan, con más de 180 kilómetros navegables. En su capacidad tiene una característica especial que lo diferencia de otros ríos, es que es el río con mayor descarga fluvial de Sudamérica. ¿Eso qué significa? Que en la cuenca, en sus deltas, se producen unos bajos de arena que representan un obstáculo para la navegación de una unidad a flote. Entonces, una unidad que tenga una capacidad con un calado menor que pueda navegar es un excelente elemento que puede facilitar la misión. La zona costera, esta es la zona costera de Buenaventura. En ese momento que contamos con dos, hay que tener en cuenta dos puntos bases, como lo puede ser el puerto de Buenaventura y la base naval Arecibo de Málaga. Entonces, si él va a hacer un ingreso a la zona litoral, se va a enfrentar a condiciones costeras, va a estar en condiciones, va a enfrentarse con el oleaje, y de esa misma manera es por eso que hemos basado nuestro estudio de maniobrabilidad y el comportamiento de la mar. La metodología la basamos en tres puntos importantes. Primero, el estudio del arte de la maniobrabilidad y el comportamiento de la mar. ¿Por qué? Analizamos todas las teorías, todas las características necesarias que necesitamos saber para poder aplicar nuestras simulaciones. Segundo, parametrizamos los escenarios de operación de la BAL. ¿Cómo así? Gracias al CIOH tuvimos datos reales de batimetría, datos de viento, datos de corriente, para poder llevar un escenario virtual, como era el simulador Full Vision de la Escuela Naval, para poder realizar un buque a la condición real, que lo queríamos, o más acercado a la realidad. A continuación, esta es una imagen del buque de referencia, es la BDA, buque de desembarco anfibio, para que se tenga más o menos una idea de cómo se espera que sería esta
This is the technical characteristics of the breadth, the width, the draft. So this is important for the to have a real image. So this is seakeeping. Seakeeping, we started with a software and computer models. This is the initial one. This is the max surf motion, where we took the vessel to the C1, C2, and C3, and then we have these graphics. Here we can observe that for each heading, the side, seeing the upper part, right side, that we use the wave spectrum. It's important because this spectrum is the one used in the North Sea, but we used it because it is the most rigorous, and it is the one that came closer to what we wanted to evaluate the project. This is the same simulation, but taken to real conditions. This was at the sea buoy. We took the simulator, the vessel with all the wind and current and wave conditions varying from 1 to 8 knots, varying 15 degrees the speed of the unit, observing how it was affected by the tilting and balancing of a unit and the listing of a unit. So we compared it with the max SOAR and the full vision simulator. In the upper part of our screen, we see the parameters and parameters used, which is defined as transit and patrol vessel. It means that it transits and patrols, and it's got the values for roll and pitch. We can see it is important to analyze conclusions about the 2 points, and that was key for the final conclusion of a project. Now, regarding maneuverability, we have another type of software, but a different point of view. We used 3 softwares because at the beginning of the project, as I said before, there was a preliminary design phase, so we didn't know what type of production was going to be used. So we used 3 simulators. The ManSim simulator, we used it with a conventional system of a propeller, then the virtual shipyard and the full vision, and then we did zigzag with the evolutive cycle and deep water and shallow water conditions in order to analyze all the results to get to the most accurate conclusions as possible. Now we have a flow chart of the operation of a simulator, Maneuver and Simulation Laboratory. This is a software of a University of Turkey, and we used it as follows. The math model was mathematical modeling group. After that, we used the entry parameters. Then we have a propelling and vessel parameters. We had something from these software. By not having these model basing, we had hydrodynamics to apply it in the software. That was of great help for simulations. Then we had the maneuvers, zigzag, and then we have all the animation and all the data. This is a clear example of how the maneuver took place. This was the helm and propeller maneuver, taking the drive. This is another type of maneuver. It was a zigzag of 10 and 20 degrees. So we focused on 2 things, the Vorsor angles, 1 and 2, and then on the right, we can see the difference between the heading and the rudder. That was the difference of data we're using as criteria to apply. The shipyard simulator allowed something, which was the comparison of shallow and deep water maneuvers to see how the vessel was going to behave. These maneuvers were executed with jet propulsion. So we were able to analyze how it was going to behave in deep and shallow waters. We did the same test with the zigzag tests in deep and shallow waters with very good results. And this was the main test, riverine conditions. So we did it in the sea, but in the river. So we used the flows, the shallow waters. We had the bathymetry of the river, and we used all the maneuvers that we wanted in those shallow water conditions with very good results that we're going to present in those analyses. This was the graphic of a zigzag test, 10 and 20 degrees in the river, the mouth of the San Juan River. And this is the criteria proposed. As you can observe, and this is the requirements. You can see that the requirements is for warships that are more demanding than the IMO requirements. So it was more rigorous for crash, stop, and zigzag, among others. One of the first conclusions we can have is that since we did 2 tests with a rudder and a propeller and jet, so we comply with ESTANAC and IMO because they're very rigorous. So we used both. That is the first discovery. Number 2, or second conclusion, is that we can confirm and validate the diameter of a turn was reduced when the vessel was taken to shallow waters in the sea test. That we got from the validation in the San Juan River and the shipyard simulator. So we were able to have a comparison of how the maneuver took place in shallow and deep waters. In the sea keeping, in open water, recommendation is that it's got to navigate in a wave below C3. If the vessel needs or is forced to navigate above C3, based on the graphic that we observed, our recommendation is that it used a heading of 060 with a 6 knots, so that the wave does not come through the aft or the bow, based on the real operativity. And the last but not least important, based on those results, we cannot guarantee the construction or the performance of these vessel, because we're still missing scale models. This could be an added value that must be taken into account as a recommendation. Last, I wanted to thank CATECMAR, the cadet school, the faculty, my colleagues, Ortega Naranjo, and project director, Jose Maria, for their support, and I'm open for questions. Thank you very much.
Gracias, Teniente Valderrama.
Thank you very much, Lieutenant. Very interesting. I believe that we were able to get up on track. I am going to check on the questions that we can have now. I have a couple of questions just in case. After checking the chat first. Captain Juan Carlos Galindo asks, what is the next step for the validation of the results of those simulations that you conducted? The answer to that question is that at the beginning of the project, we took some model basin tests. Those tests were gonna give us the hydrodynamics to have a more real approach. The next step is to develop the scale vessel and take it to a model basin and see how it behaves. I think that's the way to go based on our recommendations. So maybe that could bring us a greater contribution. Thank you very much, Lieutenant. I also have a question. I wanted to ask, based on those results, do you consider that is it possible to improve design so that the vessel enhances that criteria, so it's closer or farther from those criteria? Okay, my answer would be as follows. The vessel must have a special characteristics, like the block coefficient must be estimated 0.78. So to reduce the draft from a perspective by reducing the draft, it is going to have like a drawer shape. So it's going to have some difficulties by behaving at sea. But at that point, taking into account the requirements, we have to analyze the coefficient and the shape without losing the navigation capacity in shallow waters, but without neglecting behavior at sea. And that we can validate by the previous answer. And that's by taking it to some model basin for hydrodynamic test. But that would be in the hands of a COTECMAR design team. I think the design team is asking themselves the same questions to achieve the best performance possible. That's correct, Lieutenant. The information we got in this analysis must be used as the input for the design, as well as for the school to have a new line of research regarding the use of simulation tools, both the virtual and analytical tools to look at this type of phenomenon at the earliest stages of design. Thank you very much, Lieutenant. Right now, we have run out of questions. If there are any comments, you can take a look at the chat, but with no further questions, we can conclude the presentation now. Thank you very much for your time. It was a very interesting topic. And thank you for your comments.
escucho.
¿Me escucha, señor Omar?
Sí, yo escucho.
Ok, listo, señor David. ¿Cómo está? Buenas tardes. Por favor, ¿podría habilitar su micrófono, prender su cámara y compartir pantalla, por favor?
Buenos días, ok.
Buenos días, señor David. ¿Podría compartir su presentación, por favor?
Sí, ahorita lo comparto.
Muchas gracias.
¿Me confirma si se puede ver, por favor?
Por favor, en modo presentación. ¿Me puede dar modo presentación? Listo, aquí ya estamos viendo. Ya lo estamos encuadrando, ya terminamos de encuadrar y le damos la palabra al señor Omar para que inicie, ¿ok?
Ok.
Me das el inicio.
tiempo a las personas para que ingresen y vean la presentación, la charla. ¿Ok?
Sería 11:15. 11:15. Sí. Y listo para iniciar.
Ok.
Igual esperemos, David, a que nos den la salida.
Sí, sí, no hay problema. Yo espero.
Dos, tres, ok. Listo, ya vamos a empezar, ¿ok?
Sí.
Ok, en 30 segundos empezamos, señor Omar.
Dale, dame. Tú me das la salida.
Listo. Al aire.
Buenos días nuevamente a todos los
Good
que se
morning again to all of you attending this virtual channels to share on the presentations of our Congress. In this case, the second portion of the morning, we have President of David Sagasti Calderon from the Peruvian Engineering Society. He is a naval engineer from the University of Peru. He has experience in nuclear and compound materials. He is a member of the multidisciplinary and computational division for the naval development. Likewise, he has experience in companies like Lessers, ISIC, and Industria Franquea. His presentation for today is titled Multi-Physics Analysis of a Pressurized Water Reactor for Military Ships. So I leave you with Mr. Sagasti. The floor is yours, Mr. Sagasti. Thank you. Good morning, everyone. My name is David Sagasti, and as you've seen in the presentation, I'm a naval engineer. And today I'm here to present to you on a research performed in a nuclear reactor, fission reactor, which is a PVWL, which is a pressurized water reactor, and for military applications. As we can see in ships, the propulsion system is a very important part. Whether because when one designs a ship, you intend that vessel for a purpose, and that activity demands a time of operation which can range from 8 hours to 1 month, 2 months, depending on the activity that that vessel is intended to. Such as the case of the military industry. Submarines have operational, long operation journeys, and they need to be supplied with energy. And that is why, for instance, submarines and frigates, they use nuclear energy. However, ever since last decade, we have been trying to use this propulsion system in other types of vessels, as, for instance, merchant ships, as the Otto Hunt, which is no longer in operation. This is because they require or demand a large amount of energy for operation. Now, how is it that this propulsion system works? Let me give you an idea. It's very similar to nuclear plants. This is a 2-circuit, or actually a 3-circuit system. You consider the part where the steam condensates included in the second circuit. But in the first circuit, you have the reactor and the steam generator. Now, this reactor is subjected to a 15.5 megapascal pressure. And this is because within the reactor, there is a core that generates a lot of energy. And we have a refrigerant in normal conditions. This refrigerant will evaporate in minutes. And that is what we don't want in this first stage of the circuit, because there's water that travels out from the pipe, heat a water that is at a different pressure and at a colder temperature coming from the second circuit. And that temperature is which evaporates. And that steam then is moved through the turbines, which drive or propel an electric generator. In turn, the steam, which drives the turbines, condensates to again be used in a subsequent evaporation cycle. We are going to talk about the PWR reactors, and those are thermal reactors. So there are thermal reactors and quick reactors. And what is the difference between these two types of reactors? Well, thermal reactors require a slow neutron to achieve a controlled fission. And that neutron, a slow neutron that does the fission with the uranium molecule has to be low speed to be able to control the fission. Otherwise, it would become a quick reactor and the conditions of operations would be different. Why do we use these reactors, these PW reactors? Well, they have been intended for the military naval industry. And today, they are now being used to generate electricity in cities. But they've always been used because of their easy to operate nature. And also, the quantity of material, the structural integrity, all the physics that has been related to that. But it is worth mentioning that those reactors use a fission reaction. As I said, it needs a slow neutron that will do a fission with the core, and that yields two elements, three neutrons, and the released energy. By nature, fission is a stable reaction, which occurs for the purpose of finding two elements, more stable elements, as the end product, and as you can see on the slide. However, this sum of masses, atomic masses, is not enough. It's a difference. This missing quantity of released energy. So that released energy is expressed in three manners: in kinetic energy, in the fusion of the core, in the issuance of gamma ray and beta ray, which happens after the fission. However, for this paper, we will focus on the kinetic energy, because that kinetic energy is later expressed in calorific energy. You know, it warms the coolant. We are not talking here about particles because I don't believe that applies to the naval aspect. But for that, we use uranium rods. So fuel rods, which have pills, enriched uranium pellets, and they also we have a gas gap, and it has some cladding to it, and this is for purposes of validating the model using studying heat transfer to solid, liquids, and the type of radiation. Now, the end is to find a temperature profile in the literature here on nuclear reactors, and already talked about, and with that we can validate this simulation. Now, this gas gap is helium, and the insulation allows the chain reaction to occur. If this material had a high absorption of neutron, the reaction would end, and it wouldn't be as efficient. Now, this is the profile, the typical temperature profile, radially speaking, that you should achieve in the different variables of fuels. Now, the simulation yielded a typical profile, radially, with contrast with the validation of the literature. As we can see, it is within the operation ranges with an operating temperature of about 2,400 degrees. Well, once validating, we did the first global study, which is the study on the fuel rod, and that is an element, a fuel element, and each rod that you see there is a fuel rod with which the validation was performed. This is a 17 by 17 fuel rod arrangement, but in actuality, not all are fuel bars, but there are neutron bars. And later on, we will see why the neutron or the control bars or rods are, whether for the attraction or to serve as part of the structure of the vessel. So here we have chosen an arrangement of 17 by 17 fuel rods, but to save in computational time, we have chosen or selected a certain grid of that same fuel, as you can see. Now, we did the measurement of it for the refrigerant, which exists in that intermediary zone. We have chosen a turbulent flow based on the literature used for a reactor in Germany. So we've created a specific mesh for a dynamic fluid, and the fuel rods, we created a mesh specific for solids. Now it is important, the meshing is important because that determines the connectivity of heat and the result of the simulation. And as you can see, these were the result, internal energy. It verifies that heat is being shed by the rod and it heats the coolant, which is what I told you before. See, this coolant is ultimately shifted to the steam generator to heat the liquid in the secondary circuit. And over here, we need a time variable analysis of 60 seconds where we obtain the temperature. And we see how the reaction occurs in the center of each rod, and it expands outwards to the edges of each rod. Now, this is the typical temperature profile. It would determine also that it makes physical sense. And also, you can see that for each rod, the temperature varies. What does it mean? Well, since we already have the presence of several fuel rods transferring heat from, then now we no longer transfer heat between among themselves. And as we know, heat goes from a greater concentration to a lower concentration. We can also see that the temperature in the refrigerant increases. It starts at 553 in 60 seconds. It increases to 554, which, as I've explained, it verifies or proves that the refrigerant is absorbing heat. Subsequent to that, as we have already determined the fuel element, then we go to a more global study. Everything that we have seen corresponds to a single rod. And the computational time here, if we applied all the physics, could be up to a week. So we have taken the average time of an average heat generation of each fuel element, and we've agreed the characteristics of each. Now, this reactor is a German EWR reactor. which has 4 intakes and 4 outlets. But we see only 4 outlets, and the fuel comes in from below, from the base, and those outlets don't go directly to the flow, but they go to the lowest part, and then they heat, and then they go out the 4 outlets. So this is the inlet, and those are the outlet. It comes in with a speed of 19.5 meters per second, and it leaves with 19.5 meters per second. In the mesh, we also created a mesh for the dynamic fluid, and also for the fuel rods, or for the fuel element. And these are the results. So you obtain a high temperature at the base of the core, and at the outlet also you achieve high temperatures. But it is worth mentioning that the results here are not going to be as close to actual, because in these fuel element there are control rods, as I told you. So what we did here with the time analysis, and since we are talking about a time-dependent analysis, one would say that this temperature would be runaway, and that means that the presence of the control rods are important, because the control rods control the fission reaction. If we had not control rods, because these are changed after so much time, the reactor could collapse, and we already know that we would not only have the shedding of radioactive residues, but it would also cause the breakdown of the entire infrastructure of the ship. And if we're talking about 600 megawatts, right? And even with that amount of energy, the reactor only worked at 30 to 40% capacity of efficiency. And in this study, what we attempted to was to do a multi-physics analysis of heat transfer and fluids, dynamic fluids, to analyze its behavior in a more naval-like manner, and how this reactor affects the operation of the propulsion system of a military vessel. We can see that great internal energy is produced, and by that we mean megajoules, per second. But it is a huge amount of energy. And that is how the turbulent flow is achieved. What we were able to see, well, theoretically, the flow should go out the outlets towards the heat exchangers, right? But when we see the operation with a condition of gravity and turbulence, we see that in each outlet there are produced counterflows that contribute to the reduction of the kinetic energy of the outgoing flow. So from here, one can already start seeing that, well, we see slight reductions in operations which affect efficiency. It starts from the core, but the way that we can see things also from the outlets, it results in a slightly lower outgoing flow. Over here, we can see the conductive heat flux between each fuel element, and that means that each fuel element works at a different, operates with a different temperature, whether it be because some take long to have the fission occur in them to then start transmitting or emitting heat. Well, this is what we see on the speed, the outgoing speed. As I said, supposedly they should all leave at a 5.5 meters per second speed, but it does not happen that way. In some cases, it's lower, and other cases, it's much higher. So those are the things that we find out when we can perform a multi-physics analysis and not focus so much on the physics and particles, which as I said in the beginning, does not have such an effect on naval industry. Well, that would be it. Thank you.
Muchas gracias, David, por tu presentación. Vamos a revisar si hay un espacio
Thank you,
disponible.
David. Let's see if we have a space available for questions with the attendants could ask of you. So, questions, anyone?
Hay una pregunta relacionada con...
Now, there is a question related to this is a propulsion with a very interesting economic ratio. The question is, given its high concentration of energy, is there any nuclear development here in our countries in South America? I believe so. A year ago, I was working together with physics doctor who works in a fusion reactor in Switzerland. And so while talking to him, I asked him why, for instance, in Europe, research is done on that sort of reactor, but over here in South America, it is still not as developed. And so it all has to do with money. What I would say is that if the entire Latin America would join to fund either a fusion or fusion reactor to generate energy or to start doing research as is done in the south of France, right? I think that in the long term, Latin America could become a powerhouse in nuclear physics because there are very good professionals. I just think that we need that socialization of the information so that in the long term, people do not regard it as something hard, but something that we could do if we cooperate.
De acuerdo, David. Realmente un reto.
It really is a challenge. It poses a challenge for the entire region to develop this scenario of nuclear energy. I also had a question, David. In the result, you mentioned a limit speed of 5.5 meters per second in the outgoing flow of the nozzles. It seems to me like a low speed seen as we're talking about nuclear fission. Is that a design limitation? Was that an expected result? Yes, it is a more design-based limitation. These reactors have a certain diameter, as we know. When a flow goes through a certain area, depending on the area and the speed, of course. But this is mostly to have a controlled generation of steam. But what the results have shown is that we have higher speeds in the outlet. It is worth mentioning that we did not use control rods, and we have the control rods with a high load of neutrons, and the gray control rods which have a low absorption of neutrons. Now, taking into account this physics that can be developed in a more organized research, we would obtain results perhaps closer to how things really happen. But it's mostly design-driven, and it's in the literature. And in any information that you read about nuclear reactors, you'll find that is the case. Okay, one last question that we've been made. What is the best way to analyze the efficiency of the reactor? Yes. Well, the efficiency of the reactor can go from the design all the way to the physics that you use in the fuel rods. As I said here, the fuel rod used insulation, and that insulation a low absorption of neutrons. But why do we use that material? What happens is that when we do a fission reaction, neutrons are shed, and those neutrons will cause a chain reaction in the other field rods that exist. However, if we have a material that has great absorption of neutrons, that reaction will be reduced or not go. But if we have a transparent material, those neutrons can generate greater chain reaction. But not only the insulation has an effect, but also the coolant and its material. For instance, the coolant is heavy water at a pressure of 15.5 megapascal, and this has a low absorption of neutrons, precisely for neutrons to not leave the general area of the reactor. Well, it could be designed then, but I think that everything has to do with the materials, even in nuclear energy. In order to avail ourselves of the highest amount of energy, and we're talking about conductors and superconductors, all that sort of inconveniences with the material design, even for ongoing research projects, that would have an effect on the efficiency of the reactor. Agreed, and thank you for the response. Also, in another channel, I received a question, understanding that the analysis corresponds to a multi-physics analysis. You mentioned the subject of heat transfer and fluids as the two physical phenomena as modeled or simulated. So the computational tools that were used for this analysis, which were those? Are they off the shelf? Are they homegrown developments? I'm being asked that internally. Yes, I am using the consort Phillips. This is also used mostly in Europe, but in Latin America, it started to be used because of the management is very accessible and it is very easy to use. It is the software that uses the Cyrillic element. For that study, I used it on heat transfer both in solids and fluids. No, turbulent fluids, chi epsilon, and also heat transfer by radiation, which are the three types of heat transfer that occur in this reactor. Now, it is a very good tool to work with. The licenses, it has a cost, but it is a very good tool. I fully recommend it.
Vale, gracias, David. Bueno,
well, I believe we have no more questions from the chat box. So I have but to thank you for your presentation and hope that the university, you continue participating from the university in the upcoming iterations of the event. So thank you. And thank you to all of you in attendance. Mira, le quedaban 5 minutos al muchacho.
Muchas gracias a todos.
Gracias, David. Muy amable. Hasta luego. Sí, ya estaba difícil alargarla más.
¿Listo? ¿Me escuchan?
Sí, buenas.
Sí.
Todo perfectamente. ¿Cómo está? Buenas tardes, soy Juan Camilo.
Muy bien, muchas gracias.
¿Listo? ¿Podría compartir su pantalla?
Sí, claro. Listo, ahí se ve.
Camilo, ya estamos viendo su presentación.
Ok. Ya está listo.
Ya
Sí.
estamos acomodando acá, ya para dar el paso así, ya comenzó.
Listo, perfecto.
No alcanzo a escucharte bien, la música está muy alta. Decías que arrancamos enseguida, vamos a esperar un poco.
Esperamos un poco.
Ok, vale. Estoy atento entonces.
Ok, entonces en un minuto empezamos. Yo le doy la señal, señor.
De acuerdo, ya estoy atento.
Señor Juan, ¿usted puede bajar un poquito la cámara para que se vea un poquito más close? Ok, está bien. Juan, ¿puede modular un momento? ¿Puede hablarnos?
Sí, hola, ¿me escuchan? Hola, hola.
Perfecto, lo escuchamos perfectamente. Listo, faltan 30 segundos, ¿ok?
De acuerdo.
Listo, vamos entrando en 5, 4, 3, 2.
Buenos días, nuevamente nos encontramos en esta primera parte del...
Good morning once again. This is the morning session of this second day. Moving on to the third presentation of the day, we have Mr. Juan Camilo Urbano Gomez from the Universidad Nacional of Colombia. Mr. Urbano is right now doing control engineering in the National Universidad in Colombia. He's experienced in minor vessel control, and he's been working since the year 2018 as a researcher in the hydrometer group. Today, he's going to present the electromechanical modeling of a catamaran type boat. Mr. Urbano, please. Go ahead. Okay, good morning, everybody. Okay, I'm Juan Camilo Urbano, and I'm going to be presenting the paper that I conducted with some of my colleagues at the university and the research group in the electromechanical model of a catamaran type vessel. The way that I'm going to be presenting is that first we're going to talk about an introduction, how this model contributes to the design of a catamaran, the methodology used. After that, we're going to see the assumptions used to have a model that is the hypotheses and the definition of the subsystems. Then we'll talk about the development of the model, that is mathematically how the interactions occurred based on the foundational laws, to use the balance formulas and then other principles that complement those equations. Then we are going to present the results obtained through simulation and some of the conclusions. So first, the birth of this paper goes back to the hydrometra investigation group, where we've been designing and building high energy efficiency vessels, including catamarans, like in the picture. These were used initially to for international competitions, for example, in France. So in the group, there was the question: how to do so that before building the prototype, to know how efficient it could be and what can be corrected. In that sense, it was a need of ourselves, but to the design of the vessel, we always have this question: the need to know what are the forces that impede the drive or the resistance to water or the wind, what power is needed to achieve certain speeds, etc. And to achieve all that, what we can use the spiral design. So in essence, it consists of subdividing the system, the vessel, in smaller subsystems that interact among themselves. Right after that, we test each of these parts. And from there, we can talk about the general design of a vessel. The problem there, as we can see, is that requires a lot of interactions. Why? Because first we need to implement a subsystem, test if it works. Otherwise, corrections are needed. If it works, then it's got to be built again, and then like that. So we can build static models, and there we can identify some parts more easily. But there's always the question: how to relate the power required
la embarcación propia en sí misma, que es decir, todos los fenómenos mecánicos asociados al...
to move the vessel, with the designs associated to the movement of a vessel. This is why the integrated models tend to be very useful. Why? Because by integrating the design process from a simulation perspective and a practical perspective, taking it to the reality, we have fewer iterations. In other words, we need fewer attempts to get to the result. We can make timely corrections before moving into the design of a vessel. We have better efficiencies and lesser consumption of resources and lower costs in the design. So methodology was a methodology for physical models. The first thing is the pre-construction stage. That is, we're going to describe what processes we're going to do. What is it the maximum levels that detail engineering and those limitations in the scope? And then we subdivide the processes. That is, what systems can be identified separately to then be analyzed internally. Then we have the construction phase. In the construction phase, we talk about the mathematical equations. We identify variables, parameters, and constants to be used. We also look at the constitutive equations. Then we look at the Liberty grades. That is, that if so far we're able to describe the dynamics of the vessel, and finally, we put that all together in a computer model to run the simulation. Up to that point is where we got in this paper. Then there is the post-construction phase, that is to validate the model with a real prototype model, build it, and then compare it with the simulation. That is left for a subsequent phase, because the first intention was to confirm if it was possible to relate the power systems with the mechanical systems in a mathematical model. So let's start by describing the process. What are we going to model? We're going to model a vessel, a catamaran type bell, meaning 2 hulls. And we want to know the speed in the x-axis, that's drive displacement in the z-axis, and the power necessary for speed, the energy consumption required in a full routine, and what's the efficiency in the system propeller engine. What efficiency from the engine, from the motor, until it's released to the vessel for movement. But by having this model, we raise a hypothesis. First is that it's going to have a fixed angle. In other words, it's not going to tilt, it's not going to roll or pitch. So in this axis, it is not going to rotate. Second consideration is that we're going to suppose that the vessel is going to be moving in a straight line. So by not moving to the side, that's a simplified 2D model. The other hypothesis is that going to be a buoyant force pushing the vessel from the fluid. That is true given the Archimedes principle that let us know how much the water is going to be pushing depending on the volume of a vessel that's submerged. And we also have the dragging force of the hulls, which is going to be modeled empirically or numerically. That is, that the dragging forces are going to be taken or put through another software. And with that, we adjusted a quadratic regression to consider those dragging forces both from the rudder and the hulls. Likewise, another hypothesis is that the propulsion force, the drive, is determined from the OpenPro software. This software, based on the geometry of a propeller, delivers 3 values, which is these 3 curves here. 2 parameters, KT and KQ, and the efficiency of a propeller. They all depend on the drive number J, which is going to depend on the speed of the rotation of the engine, and that's what's going to give us the information for these parameters. And the last assumption is that we are going to suppose that the geometry of a vessel is a sphere. This added mass is that mass is like what's added to the vessel when it's moving forward. It's like the small particles of water were added to the full mass of vessel, adding additional weight. So to run that model, we assume that the geometry of the vessel is like a sphere. With this, so we propose the process system. So we subdivide what we're going to analyze. On the one hand, we have the mechanical system, that is the physical vessel as such, the whole rudder and the engine, physically speaking. And this is a graph, a diagram uniting the forces affecting the vessel. So we have the dragging forces, we have the weight, we have a buoyant force. And here we said that we have a fixed asset, a fixed angle. when we talk about this model basin tests, so we can fix that front part of the vessel, so we can fix the angle. So we model that with a buffer and a resistance. Then we have a power system, all the electrics. And for that, we want to work with a brushless continuous current motor. These motors are being used today due to the high energy efficiency, and that they're very versatile. And this was one of the factors that we consider, and it was the relation between these AC brushless engines and the mechanical system. So these two process systems come together as follows. The engine receives the voltage, which is the power delivered. And with this, based on that voltage delivered, then we have the current coming out, which produces the necessary torques. Then the motor delivers to the vessel an angular speed. Depending on that speed, the catamaran is going to behave in one way or another. From the catamaran, we're going to take the speed in the drive in the x-axis, then the height in the z-axis, and the speed of the displacements in the x-axis. Finally, the catamaran sends back the load torque. In other words, what the catamaran needs to move under these conditions. And this is how the motor and the vessel relate to each other. So with this, once we have this all clear and we build all these equations, in the case of a sum of forces, you know that the second law of Newton relates the multiplication of a mass by acceleration with the sum of forces in this axis. So we have horizontal component of a propulsion force. We have the dragging forces of a hull and the rudder. And this is the vertical component of a propulsion force. This is the weight, the buoyancy, and the forces created by these settings, these fittings, the spring and the resistance. So regarding the engine, having this three-phase motor brings three equations that represent the Kirchhoff laws. So each of these lines show the sum of a voltage. So we can see that this is the sum of the voltage in line A, the resistance voltage, and this voltage here is an induced voltage resulting from the induction laws. So if we apply that for each of the three lines, we have these three equations. Following the balance equations, we would have to do a torque balance, and that is again the connection between of a mechanical system. And this is the rotor multiplied by the variation of the angular speed. This is the electrical torque of the engine minus the torque imposed by the catamaran and the torque of viscosity, which is produced by the viscosity of a medium of the rotor. Then we analyze the variables and parameters and constants that we need to know, or that we have found so far, or that will appear in the future. So regarding variables, we have a voltage and a current in each of the lines, line A, B, and C. We have the angle of the motor, the angle of the rotation, the angular speed of a motor. This is rad per second. Then you have the incoming voltage, the one coming from the batteries to the motor. We have the speed of a drive, the position in the z-axis, and the speed in the z-axis. As constants, we have gravity, we have water density, and the specific weight of the water. In parameters, we have or we must know the parameters of the engine of a motor, all the characteristics from L to J sub M, these parameters must be known. Otherwise, we would have to characterize or describe the motor. Then we have the diameter of a propeller, the angle of drive, the mass of a vessel, the K mass, and then the constants to keep that fixed angle. Once we have determined the balance equations and the variables, parameters, and constants, then we proceed to find what equations describe some of the forces that we have described before. So propulsion force is calculated with this K sub T, which relates the propulsion force with the density of the fluid, in this case water, the RPMs of the motor, and the diameter of a propeller. Remember that this KT factor is part of the hypothesis that were obtained through the software. Then we have the rudder dragging force, a quadratic expression. There was a numerical regression that takes the speed of a drive. Then we have the hulls dragging force, which depends on the drive speed, but also the draft. And the draft is what part of the vessel is under the water line. And then that's how we can find it. Again, these equations here, these last three, were used to obtain the data and run the regressions. Moving on with the constitutive equations, we have the buoyancy. As I said in the model, hypothesis depend on how much is under the water line. In other words, it's going to be the draft. Then we have the spring force, which is the displacement of the elongation of a spring, and the buffer force, which depends on that displacement in the z-axis. That was the mechanics. Now, regarding power, we saw that it is a brushless continuous current motor. In other words, that the batteries deliver the voltage in continuous current, but for the motor to use that voltage, that energy, we use a circuit before delivering to the engine, which is called an inverter. And the inverter is summarized in this table. So it takes the UA, UB, UC voltages, and that's going to be determined by the angle of the engine. So there's going to be a line that's going to have the half of that voltage. The other line is going to have that same magnitude, but negative, and the other line is not going to be connected. That's going to happen according to this computing table. And again, the one in charge of that is an external circuit that can be simplified in this table we're presenting here. So we have left the voltage induced in each line. We saw the E in each of the lines, and that's run through this equation. We have the constant of the motor, the RPMs, and this F function, which is going to be different for each line. So the F function is summarized in this graph, and it depends on the angle of the motor. That function is going to be delivering the energy depending on the phase, depending on the torque. In each of the phases, we can determine that as a constant, and the multiplication of the same function times the current in that phase. In addition to that, we have the torque generated by the propeller, as well as the propulsion force. This is taken to this I-dimensional model, taking this magnitude here, very similar to the propulsion force that was obtained to the same software. So this constant is obtained to that same software. And then we have the viscosity friction torque, which is the angular speed of the motor. Once we have identified all these equations, We identify the constitutive equations complementing the balance equations, and we determined the constants and parameters. Then we have everything necessary to run this in a computer model. In this case, we used MATLAB. As the input, we have the voltage added or delivered to the motor. That voltage starts in 0 to observe the starter and the dynamics of that variables. It goes up to 160 volts. Then we decided to bring it down to 100, and then we took it back to 160. The purpose here was to see that that input voltage that's under it's independent, but that relies on the variables that want to be found. So let's look at the results of these simulations. Regarding the speed of the drive, we see that with the highest voltage, we go up to 5.5 meters per second, then it goes down to 4 meters per second, and then it goes back to the speed that we had before. It makes sense. If we increase the voltage, then we have a higher speed, and then with lower voltage, we have a lower speed. Regarding the height, the intention of that anchoring is to guarantee that the angle is constant. But since this is not a rigid structure, it doesn't avoid displacement up and down. So we can see that the maximum it can go is 1 millimeter. This is a 2 millimeter scale. So the propulsion force, the highest pulls it up a little bit more than when we are sending the lower voltage. Regarding the average power, and then here we can see the most interesting results, and the average power it tells us what motor we have to use. If we want to go up to 5.5 meters per second, then we need a power of 3,500 watts approximately. So if we have that in a lower level, we're going to have to get a different motor. We can also see that if the necessary speed is lower, then this power here would be just enough. Then we have the energy consumption. So this let us know what energy we're going to be using by the end of a trajectory, or if we have some loading stations. So in 60 seconds, we had used 35 watts per hour. So if we want to extrapolate this, and if I want to know how much I need to move this for 5 hours, then I could have an estimate of the necessary amount. And then we have the two results that in our criteria are the most relevant, and it is the efficiency of a motor propeller system. What we see in this graph is that in the highest speed, efficiency is lower, is 40% approximately, whereas if we take that speed down, efficiency goes up. That can be represented too in this chart here, comparing efficiency with the speed. And here we see that when we get to the 5.5 meters per second, efficiency is 40, but if we reduce the speed, the efficiency goes up to 47%. And then as we increase speed, efficiency decreases. This is very useful because with this, we can find a specific speed where the system is most efficient. If I have a limited amount of energy and I have to achieve this goal, then I have to go at the speed in which my system is most efficient. So, concluding, we have that the determination of energy consumption can also affect the economics and the environmental aspects. In economics, because by being more efficient, we need to use less fuel. And also because if we want to be more efficient, and if we don't have these computer models, we always have to do all these iterations. and that has a cost. And environmentally speaking, we have the fuel consumption too. On the same line, when we verify the parameters in the design through the model, it gives us a more precise model. That is, before building the vessel, we can have an approximate, and we can run the corrections before the construction. And finally, for a better competitiveness, we must increase the freedom grades. I mean, we here suggest a fixed angle, and we can make it more real if we vary that angle. And that would be all, and this is part of the literature used.
Muchas gracias, Juan. Muy interesante.
Thank you very much, Juan. Very interesting. And just in time, we are going to check if there is, there are any questions from the audience.
Yo también anoté algunas preguntas.
On my side, I also made some notes here, but let's go ahead and check for the chat questions before.
Voy a ir formulando las preguntas que tengo acá directamente.
I'm going to go ahead and ask the questions that I have. First question is, given that all this analysis was run by integrating the electric motors over a competition model, not real scale vessels, how scalable do you think this methodology is in electromechanical models for real scale vessels for testing or during operations? Is there any type of limitations when going from the application of a method, or it can be used in real scale vessels? Okay, this is fully scalable. Oftentimes we use tests in model basins using 30, 35 centimeters prototypes, and that can be scaled up to a real size vessel. In the same sense, this model allows us to work with the parameters, because this is inputs to the model. It doesn't matter if it weighs 100 kilos or 10 tons. All those parameters are input to the model, and the model takes all the physical dynamics using power and displacement. So if we have a high power motor, we would only have to change those parameters in the motor. Okay, that was clear. One last question that I have here. And this one is about the experience that the Hidrometra group have had in the hydro contest events, knowing that the experience you have had has been improving. Every participation you have had a better performance and results. Question is that part of that improvement in the result of the group in the hydro contest is related to having implemented these models in those stages, or the electromechanical model has been a development after the participation of the group in the hydro contest. Regarding the hydro contest, this paper came after, because the participation in the hydro contest ended in the year 2018. That because of the logistics and so on. So from there, we started to work. So we wanted to go back to the competitions, but to get there and to be better improve. We wanted to have a model so that we could use it to build a better boat. So it was the result of all the work we had done before, but also looking into improving and keep at the helm of these competitions. Okay, thank you very much. Juan, congratulations to the whole research group. We understand there are quite a few individuals behind all this development, multidisciplinary group from the university. So we want to congratulate you for the work done and the performance of investigation group and all those competitions that you've taken place. So we encourage you to carry on always improving results and at the same time understanding all the phenomena that will make us more efficient when building and using vessels. Thank you very much. And thank you everyone for being with us in this morning session in our second day. So this is the end of this first block, and then let's resume at 2 p.m. for the afternoon presentations. Thank you, everyone, for your participation. So this is how we end the morning session. And next, we can have a break and resume at 2 p.m. with the technical presentations.
No, esa de pronto le molesta que caiga ya, pero ella es no, sí, sí, ahora estaban cuando cuando me mandó un mensaje de y es cierto, lo decimos ahora con él y se escucha sí,